Please take your seats. The program is about to begin. Please take your seats. The program is about to begin. Please take your seats. The program is about to begin.
We have an opportunity to develop technologies that are going to revolutionize triage and the way we respond to mass casualty situations.
The teams have come together from all different kind of walks of life and different angles to really put together really successful technologies in their own right.
Anything we can do to lessen the burden on our military and our first responders is just paramount.
You know, this is such a different environment than being in a classroom or being in a laboratory setting. This is building and training the next cohort of researchers that are going to advance this technology even further in the future.
We're putting in hours, we're putting in extra time, and we're always going to push the boundaries a little bit.
Our goal as a team is really, it'd be fantastic to win it, but we really feel motivated to field a system that makes a difference.
The virtual competition affords us the ability to shift how we simulate a mass casualty incident.
What we're really interested in seeing is what the carryover is between the virtual and the physical settings.
I think there are a lot of opportunities for the kinds of algorithms that we're developing under the data challenge to benefit where medical expertise is not available at the amount that is needed in a moment of crisis.
It's really been exciting to see how teams work together.
The ability to collaborate, to have conversation with our competitors has been invaluable.
What DTC is building is a really important and unique data set on all sides of the challenge that I think will hold value long after the challenge is over.
Please welcome DARPA Triage Challenge Program Manager, Dr. Jean-Paul Chrétien.
So yesterday, we wrapped up year one competition for the DARPA Triage Challenge, so 1 year down and 2 to go. We had dozens of teams across the 3 competitions, the data, the virtual, and the systems competition, and they were from all over. They were from across the country, they were from abroad. We had large interdepartmental university teams, we had small businesses, large R&D organizations, we had individuals, we had a technology club from a university, and they all had different and innovative solutions for the core problem we're trying to get at in the DTC, which is in a mass casualty situation, whether that's a natural disaster like an earthquake, battlefield situation, anything where there's a lot of casualties and not yet many responders, how can we use technology to enhance the capability of those responders, help them make better decisions, and save more lives? It's about revolutionizing triage, and triage is quickly figuring out who most urgently needs care in these situations. So we want to harness artificial intelligence, sensor technology, robotics, other technologies, bring those capabilities together and help responders make better decisions and save more lives. So this is the central goal of the DARPA Triage Challenge, and this is what all of these teams are working towards. So we're here today to celebrate everyone who participated in year one, because all of you, every single team, brought something unique and valuable to this competition. So I want to thank all of you for participating. You've already moved this nascent field forward. It's a competition, and we're keeping score, and so we're also here to recognize the winners. And the teams don't yet know how they did, and so they're about to find out. So we're going to go through each of the 3 competitions one at a time. We'll start with the data competition. And before we get to the prizes for best performance, we're going to continue a DARPA Grand Challenge tradition, which we call superlative awards. So these are special awards. They don't come with a trophy or a check. They come with a certificate. These are bespoke prizes, and they're for things that we recognize the teams are doing during the course of the competition that we think are interesting and want to recognize. So if we call you out for a superlative award, if you're here with us in the room, please stand so we can recognize you. Don't need to come down to the stage. We've got your certificate outside, and you can pick that up later on. And if you're online, we'll send that to you. I will note that several folks from the data and the virtual competitions are not here in person. We've been here in Georgia for the past week, mainly running the systems competition. Data and virtual teams didn't have to be there for that, so they're not all here today. So let's go to the data competition superlative awards, and let's tee up the first award. So the first superlative is Best Accuracy Across LSI Award. LSI is life-saving intervention. So in the data competition, we provided teams clinical data from trauma patients, and their task was to predict the life-saving interventions that those patients would need. Now, because of the nuances of the scoring, how we do the prizes is slightly different from simply best accuracy. There are some other things we consider, but this is obviously a really important metric. So we want to recognize a team that did a great job with this. And this award goes to Team AI Tempo. All right, we've got a few more data superlatives. The most stingy with crystalloid products award. So clinicians in the room will probably immediately get this. If you're not familiar with the term, crystalloid is a fluid like saline that is sometimes given to trauma patients and people with other injuries and illnesses. It's not used so much these days for trauma, has been used a lot in the past. And in one of the data sets that the teams got, some of those older data, there was a fair use of crystalloids products. So this team, I think, recognized that developing algorithms to predict the need for crystalloids probably not as valuable in the real world as predicting the need for, say, blood products or life-saving airway interventions. So I think what they did is they tweaked their algorithms to go after those more significant interventions instead of predicting crystalloids, even though they could have gotten more points by predicting the use of this product. So that's what I think they did, and they've got respect for that. So let's give this award to Team Critic. Here we are. Thank you. All right, next up, the Penny Pincher Award. In the data competition, we provided cloud computing resources for everyone, but everyone got the same budget, so we didn't want any team to do better just because they could throw more GPUs at this. So everyone got this common budget, and some teams blew right through that, and other teams were very frugal. So the Penny Pincher Award goes to this team, Team TrueFit AI. All right, so you can guess what comes next. The Big Spender Award. No explanation needed. This award goes to Team MSAI. All right. So next we're going to go to the prizes for the data competition, and we actually have two forms of prizes in the DARPA Triage Challenge. So we've got the top scores, and so we're going to recognize the teams that got third, second, or first place in terms of the score. But we also have cash prizes. We have potentially three cash prizes for each competition: a third, second, and first highest cash prize. And those don't always align. And the reason for that is that in the DARPA Triage Challenge, there are teams that we are funding to participate, but we also have teams that have funded their own way in the DARPA Triage Challenge. And in this first year, only those self-funded teams are eligible for cash prizes. So the DARPA-funded teams can win trophies, third, second, or first place. The self-funded teams can win the cash prizes, and they can win the trophies too. Now, in this case, those two actually do align because, and this is a spoiler, the self-funded teams actually took third, second, and first place overall. So if I call your team's name for an award, please come down to the stage. You can come down on your right side here, and we'll give you your trophy and your large, physically large check. Amounts are pretty large too, and they'll get larger in subsequent years. Anyone from your team is welcome to come down, and we'll get a photo with you. And if you're not here, then we'll make sure you get those in the mail. All right. So we'll start with third place for the data competition, and this is a $20,000 prize, and this goes to Team Kama. And they're not here. So. Thank you. All right, second place. And second place comes with a $60,000 prize, and this goes to Team MSAI. All right, and first place, so the winner of the year one data competition and the winner of the $120,000 prize is Team Coordinated Robotics.
Thank you.
Nice job. Thank you. And finally, for the data competition, we'll show you the final leaderboard so you can see how all the teams did in year one. All right, let's go to the virtual competition next. And again, we've got some superlatives. And I think you'll find these to be interesting. We're getting a little bit spicier in the superlatives with the virtual competition. So let's tee up the first one, the Virtually Impossible Award. So we want to recognize a team that impressed us with remarkable speed in assessing casualties in the virtual environment. So the way the virtual environment works is you've got a system like in the systems competition, just all in a virtual world, and it goes through the scenario, and it has to autonomously evaluate casualties, their injuries, their vital signs, and submit reports. And this team did that with almost time-bending speed that perplexed us at first, but we looked into it, and it all checked out, and it's all good. So the Virtually Impossible Award goes to Team Engineering Dynamics. Nice job. All right. The next superlative, and this one actually pains me a bit to give. This is the most second-guessing award. So the way it works in the virtual environment is your system goes and you evaluate a casualty and submit a report. But you can go back to that same casualty and submit another report. And what counts for the score is the final report. So if you get it right the first time and then go back and change it, it's actually possible to lose points. So watching this team's performance, we could see their score going up as they were really hitting the reports correctly, but then they'd go back and start taking points away from themselves. So what I want to say to this team is, you got it right the first time. Next time, go with your gut. Don't second guess. This award goes to Team Flying Fitches. Nice job. All right, next up is the Most Consistent Vitals Report Award. So vitals here refers to vital signs. So these systems need to report on each casualty's respiratory rate and heart rate. And what we noticed in this team was an impressive invariance in the numerical values that were reported from these casualties. So what I'd like everyone to know about the virtual world is that we at DARPA and our partners at ARA have put a lot of thought into this world. It's a rich environment, and the metahumans in there, they are all different and special. So now you know for next time, but good thought. So the Most Consistent Vitals Report Award goes to Team Robotica. All right. So next we'll get to the actual prizes. Now, for the virtual competition, all of the teams are self-funded. So DARPA did not fund teams to participate in this. Everyone is participating on their own. So in this case as well, then, as in the data competition, the prizes and the cash line up. So if I call you and you're in the room, please come down to the stage and get your check and trophy. Although some of these folks are not here. Again, it's mostly systems folks who are in the room. All right, so let's start with the third place award, which comes with a $10,000 prize, and that goes to Team Engineering Dynamics. Good job, Bethel. All right, and the second place award for the data competition, which comes with a $30,000 prize, this award goes to Team Robotica. And first place in the virtual competition for a $60,000 prize, Team Coordinated Robotics. Nice job. And we'll show you the final leaderboard so you can see how all the teams did. It was really a close race at the top there. Okay, And finally, we will go to the systems competition. And again, we'll start with the superlatives. The Best Code Comments Award. So what you need to know for this is that in the systems competition, as the teams are out running their courses in the mass casualty scenarios, in the command post, we've got a lot of monitors, and we're looking at camera feeds and data feeds. And we also have a mirror of the team's base station monitor. So teams, when you're at the base station, and you know this, we can see what's on your monitor. So if you have code running across your monitor, or you're editing code on the fly, that's displayed on this giant screen, and like 20 people are looking at it in the command post. So for this team, we caught some things in the code as they were going along, and first of all, good on you for commenting on, including comments on your code. We weren't sure whether these were Easter eggs or stuff that you forgot we were looking at, but in any case, we thank you for the color that you added to the competition. The Best Code Comments Award goes to Team AirTags. You can explain yourself at the break, maybe. All right. The next superlative is the Smallest Team Award. This could also be the Courage Award, the Army of One Award, if you remember that old slogan. I didn't think that it would be possible for one person to come to the systems competition and do everything that's necessary to compete. But this person did it, got to every course, and so much respect for that. And that superlative goes to Team TTT. Amandeep. The Most Attention to Detail Award. This team really impressed us with how carefully they read all the information we provided to them, and how they took advantage of every opportunity we provided to them to practice before they got to the competition, submitting reports to the test server, and then all the opportunities we provided during the competition week. And they even did a service to the entire field by catching an error that we had made in one of the documents that we had released prior to the event. They caught that, they pointed out, we corrected it, and so everyone benefited from that. Team DART. The Longest Distance Travel Award. So this team, I think, captured everyone's heart who saw them or interacted with them during the competition. They came a long way. They were not funded by DARPA. They had to figure out their own funding. They built their own platforms, and they competed on every course. And it was really a joy to watch them. For some of the teams, it's sort of controlled or maybe even uncontrolled chaos down at the courses. This team really worked well together. They were quiet and just got the job done. But this award is for longest distance traveled, and that goes to Team UAS, Delhi Technical University. The In Real Life Triage Award. So real life triage was not in our plan at the DARPA Triage Challenge. But one day, a couple of days ago, a member from one of the teams was driving to the DARPA Triage Challenge course when they came across an actual mass casualty incident. They were first on the scene. This was a multi-vehicle collision on a highway, and there were several people who were injured, including some very serious injuries. So this person who has medical training got out of their vehicle, rapidly did triage assessment of all the people there, provided life-saving care until EMS could arrive. And the other note here I'll make here as an aside is that this person was not coming to compete on the course that day. They were coming to offer a ride to one of their competitors so they could get their equipment down to the courses. I think that speaks to the camaraderie that we're starting to see building in this community. But this award for in real life triage is someone we're proud to have part of this community, Team Chiron, specifically Dr. Ellenberg. All right. So next we'll get to the prizes. And now for the systems competition, we do have a divergence between the prizes in terms of score and the cash award. So we'll do the prizes first. So these are the trophies based on score. Third place in the systems competition goes to Team RoboScout. Thank you. Hey, nice job. Thank you. And second place in the systems competition goes to Team Coordinated Robotics. Thank you. Nice job. Good job, guys. Good job. Good work. Good work. Thank you. Good job. Thank you. And now, first place in the systems competition, Team DART. Hey, nice job. Nice job. Okay, and now we'll go to the cash prizes for the systems competition. So if you receive one of these cash prizes, again, please come down to the stage. We'll give you oversized check. We have 2 cash prizes instead of 3, just because of the way the self-funded teams did relative to the total field. All right, so the first prize for $60,000 goes to Team UASDQ. There he goes. And our last award for this morning, the $120,000 prize for the systems competition, goes to Team Coordinated Robotics. And then you see the final leaderboard for how the scores worked out at the end. All right, so a couple more comments, and then we'll go to break. We would love to get photos of every team that is here with their banner. So if you just received a trophy or one of these checks, please come down during the break, and we'll get a photo of your team with your banner. We want to get photos of everyone else with their banners as well. So, so for other folks, you can find us during lunch or at the end of the day, and we'll get a photo of you with your banner. We also have coins, special DARPA Triage Challenge commemorative coins for every team, which you can pick up at the registration desk. And again, the superlative certificates also are available at the registration desk. So that closes out the awards part of it. Really fabulous job to all the teams. Gotten us off to a great first year, and can't wait to see everyone back next year. Let's give yourselves a round of applause for Band.
This concludes our awards ceremony. Enjoy a break, and the seminar will begin at 10:40 a.m. During this break, teams are welcome to come on stage for photos with their banners. We will resume soon. Please welcome our DARPA Triage Challenge Data Competition Team Leads and Panel Moderator, Ben Scarrett Davis.
Hey, good morning. Hey, good morning. Good morning. Good morning. Hey. All right. Morning, everyone. I think for those of you who don't know me, or maybe only know me by my forum handle or email address, my name is Ben Scarrett Davis. I'm from Johns Hopkins University Applied Physics Lab, or APL. We've been working really closely with the DARPA team and their partners to make sure that the implementation of the DARPA Triage Challenge really meets the goals of the program. And we've been doing that in a few ways, designing the metrics, preparing data sets, and participating in the evaluations across the competition, and also interacting with teams. And it's really exciting to have you all here today in person, virtually, and I'm excited to kind of find out how the past year went. So welcome. I think to start out, I wanted to maybe start at the beginning, get a sense of how your teams came together, the different expertise that you leveraged, different experience levels. And so I'm gonna kind of open it up with that. When you first speak, if you can give us your name, your team name, your organization. Anybody want to start out?
Yeah, sure. So I'm Chase Cockrell from the University of Vermont. Our team name is Austere. And so we really tried to focus on bringing in clinical knowledge. So we have two clinical experts and then some junior machine learning people. And the focus was going to kind of be to use the clinicians to determine which data elements are going to be most informative to make smaller and more generalizable models.
So those are two very different backgrounds. Were they working together most of the time? What was your kind of rhythm of collaboration?
Yeah, they were working together most of the time. So one of the clinicians was a resident in his research year, and so he contributed a lot to integrating the clinical knowledge and the machine learning people. And I hope he learned a lot about computation and stuff too. But he was really invaluable having that translator to go from clinic to technical.
Yeah, makes a lot of sense. Anybody else? Anything they'd like to
Sure.
share? Yeah.
So I'm Kevin Knadler from Coordinated Robotics. My wife Heather did the modeling work for this, and I did the programming. And then we had Chris, who did our Python consulting for this. Our focus was really on trying to, even though it was a year, it's a very short time frame to get all the processes in place, get the data running. And so our focus was really just on getting those processes in place and being able to test that data and focus on it. And so we've been working hard on just the basics.
That's awesome. Yeah, I wanted to come back later and kind of find out how the sort of the cadence of work throughout the year looked. I think there was a lot of evolution in data provided from the workshop to the challenge. So we'd love to come back to that later in the hour. Anybody else have anything they'd like to say about their team? Makeup of, younger, less experienced people with more experience, or any sort of any other kind of takeaways. Also, to anybody on the virtual side too, remote.
Yeah, go next. Yeah, so my name is Jeff Webb from Kitware, part of the Alice team. So we had kind of a multi-diverse team, and our approach may be a little different from some other teams. And so, on the on the Kitware side, our team, I want to give a shout out to Jared and Aaron and Rachel, who's here with me. And so we did a lot of this kind of software and deep learning side of things. And then we also worked with a company called SoarTech, and a shout out to Bob, who he worked on more, using clinical expertise to have sort of a decision support kind of tree tool. So it wasn't using kind of the sort of algorithmic approach. It was kind of using decision trees that was more based on our clinician SME's input, who was Kyle at Geneva Foundation. So he's a major, and so he helped us tremendously in telling us, learning that, for example, crystalloid products is something that's not used much anymore, but for the data sets that we had, of course, that came in very handy. And so he was really helpful for understanding sort of why they would use it and how we can use that in our algorithms to kind of come up with predictions. So
nice.
Yeah.
I think this combination of expert knowledge with machine learning and algorithms is just really interesting in this part of the competition. Is there anybody who could speak to kind of how you encoded that expert knowledge? Like you mentioned decision trees, but I imagine there were probably some other approaches that people used. Anybody online, actually? Let's go to the, yeah.
One of the approaches we found useful, so we tried some of the clinical knowledge we got from clinical staff, and when we ran it on the data set, it wouldn't match because it would create false positives. So what we did is we had to, one of the approaches we did was run the algorithm, like the strategy of, taking a particular LSI and matching it up with the stochastic. So when you train a model, a naive Bayes or neural network, they train basically a stochastic decision based on statistics of what the data set includes. And we included that expert basis and used that to filter the decision of the basically classifier. We improved some of our basically specificity and sensitivity using that approach.
Nice, thanks.
So I'm Kelly, I'm on the Lens team. So we use some of the clinical expertise to create, guard statements or conditions that had to be met before we predicted. We found in the workshop that some of the machine learning models tended to predict LSIs that just, they picked up on something that could be an indicator, but there were other factors that just made it highly unlikely. So then in the, I guess for the challenge, we tried to put in some of that logic just so that we were less likely to have false positives.
Thank you. Yeah, and I'd actually love to hear more about approaches in general. I'm hearing a lot of incorporating expert knowledge kind of at the beginning to filter out things, or kind of after applying some statistical models or machine learning. But maybe to broaden that, any surprises along the way as you were developing your approaches? I think there's probably a really wide variety of ways to approach the problem that's represented here, and probably a lot of dead ends along the way. So yeah, curious. Yeah, please.
Yeah, so I'm Colin Dunlap from Battelle. Our team is Continuous Review and Intervention for Timely Care, or CRITIC. We took a very AI, deep learning heavy approach. And so one of the challenges that we'd faced is early on we had developed models, fleshed out proof of concept on open source public data sets from scientific literature. And we actually found that they didn't always translate one-to-one coming in and applying them on the RITMO data set. There are more data dropouts, large artifacts in some cases, and when we took a lot of our model hyperparameters and tried to translate them, we would have many cases where models didn't converge. So that was a bit of an adjustment for us, and even just trying to understand, what's going wrong here, and yeah, that was a really unique challenge to this program.
Please.
Yeah, so I can go. I'm Meryl with Team AI Tempo out of Michigan Tech, and something that our team was very focused on was trying to look at different features and determine which features actually statistically really correlated with receiving LSIs. And one of the things that we found really interesting, because on sort of first glance, the two, knowing what institution someone went to, either a UPenn hospital or a UMB hospital, seems like it should be the driver, but that actually did not make our final model. So
interesting. Yeah.
And that's, I think, something that really helped us get sort of the highest accuracy, is that we got a model that was a little bit more generalizable out of that by taking the institution out.
That's great. Yeah, I'm hearing two different themes. I think one is the sort of like, so I guess for those people who may not be familiar with the data competition as much, and those people watching online, we provided essentially real world physiological and health data from trauma patients from two different hospital systems in two different geographic regions, two different kind of populations that were there. So, we didn't do a lot of the kind of cleaning and culling that happens when you're working with a lot of research data sets. And so, yeah, I think, I'm really curious to hear more about how teams kind of approached the sort of real worldness of the data. And then also, I think in the same vein, in what ways did your approach leverage the two data sets together versus treat them as two kind of separate populations? Anything there that pops up? Yeah.
Yeah, well, we never really tried to consider them as two separate populations.
Mm-hmm.
We kind of thought that given the goal of the challenge was the discovery of generalizable signatures, we kind of thought from the beginning that we should synthesize the data sets with their common elements as to the best that we can, including a few variables that were unique to each institution, but really just to try to look for the commonalities between the two.
Mm-hmm. Mm-hmm.
I would second that. Our team took a very similar approach where we did not differentiate between the two different data sets, and we tried to create a system that would work for any data format, and really looking forward to the future. If more data sets come in, having a good approach that can handle that.
Yeah. Great. Yeah, did any sort of surprises along the way with the data itself, like the noise in the data or the missingness, and like how did you, if there were surprises, kind of how did you kind of navigate around those, or what solutions did you come up with? Anybody online? I don't want to leave you guys out.
Well, the surprise we had is the more complicated models that integrated the time series data were performing worse in the total score because of false positives. So we didn't have enough time to. So we, in the final model that we submitted, we removed time series and only included trends.
Great.
I think something that sort of surprised us about the data set was just how much information was potentially available in the electronic health records data. So the amount of fields was something that, I think we weren't expecting. Of course, that made it a little challenging because a lot of those fields weren't actually filled out or didn't have data. And so we were getting a lot of, essentially sparse vectors. So we used some natural language processing techniques to make embeddings from the health records data so that we had more dense representations for model training. And that seemed to work pretty well in terms of accuracy. And I guess just to, we at first were looking at a joint model, but found that the class imbalances and the LSI distribution between UMB and UPIT were just so significantly different that sort of in our final stage, we did split that apart into two separate classifiers. Though, if we were to continue, we'd hope to unify those again.
Interesting, thank you.
Yeah, this is Fendi Shingbabetz with Team Robotica. I would say we were surprised how seemingly little some of the LSI groups were represented in the training data. So we were having some challenges with building a model such that there was even a chance of having these LSI predicted by our model. The other surprise was that there were potentially lots of fields, or lots of fields have potential to be available. But when we kind of looked at all the data together, many of them were just present so little across all the patients that we decided to remove many of them from consideration and just built our model on a quite small subset of what was theoretically available.
Yeah, I appreciate it is definitely a capital C challenge. There's a lot stacked against you guys. You've got a wealth of data, but it's noisy, it's sparse, and I think we're all still trying to figure out what to do with it. So I'm excited to see how things progress. In terms of the physiological signals versus the health record data, and then the sort of the trends or the kind of window statistics versus the time series data, was there a certain part of the data that you focused on in your development or in your final model?
So
yeah, please.
We ended up focusing on the trends and the EHR data versus the time domain data. That was more of a time constraint because there's such a large amount of that data, and there were more gaps and errors in that had to be cleaned. The other data had a few gaps and issues, but it was much cleaner to deal with.
Yeah, and I'll say we took the opposite approach just because of our strong background in signal processing and data fusion. We focused a lot on the full real-time signals and trying to get information out of those and trying to figure out what pare down, because there is so much data available there, trying to pare that down to what can you pull out of that that's most useful, because obviously you can pull an infinite number of things out of it. So yeah. I would say we did use everything, but that was where we spent more of our time, was trying to look at that real-time signals.
Yeah, well, I applaud you. This is definitely a lot of data to work with and hard to know where to start. Yeah. Anybody else? Any part of the data that you spent the most time on? Yeah.
Yeah, I think going in, myself and our team, we have a strong background in time series data, so we came in thinking we'll spend a lot of time and effort looking at, for example, the ECG waveform, which it's the most popular signal in the data set. And we very quickly realized, looking at the data and different analyses, how important the electronic health record information is, how important some of the trends are. So both from the workshop, the results we got there, and just sort of the evolution, we ended up shifting from that very intensive time series analysis and started to reemphasize some of the electronic health record information. And I think that also helped with the online inference time. We didn't spend as much time computing some of those really heavy, intensive, or compute-intensive signatures.
Yeah, one thing we noticed when we were looking at even just size of submission, there's a lot of variety, and it seemed, we didn't peek under the hood, or we're unable to peek under the hood, but kind of in sort of the heftiness of people's submissions. Is that something that you were keeping in mind as you were developing, or were you more following the kind of the performance of a model, and that kind of drove your decision on what to go with? Anybody online?
Yeah, so I would say that we tried actually two approaches. We had an internal kind of competition, and we didn't have, for time constraints, we didn't have any time to properly analyze this time series, but we had expert opinion, like medical doctor opinion on, for instance, crystalloids, that we should calculate PPV and SPV, for which we need the atrial wave form. But then when we look at the data, there's only 200 patients that had the atrial waveform data. So again, we found that this is not going to really, we don't have enough time to just improve our score on those 200 patients. So we focused on PPG and ECG, and I mentioned before, with PPG and ECG, which actually works well across both hospitals, because a lot of patients do have that those signals. We found that still, we introduced a huge delay, because of processing all these signals, for some patients have hours and hours of recordings, takes a significant amount of time, and it doesn't improve the results significantly enough, at least in our early, we didn't have enough time to spend on it, that we decided against using it. So yeah.
Yeah, I think maybe one of the other parts of the challenge this year was just the volume of, or kind of the spin up time and the the acclimation time. I'm curious about how the past year went. When did you feel like you were starting to kind of get your handle on the data and able to focus on sort of your algorithm development?
I would say after the workshop, we started
being
able to hit the ground running a little faster. I'm probably not the only team member that had problems with AWS and SageMaker, and so once we got that initial submission, then we could really kind of start actually really training the algorithms and focusing on it a lot more. So I think that was nice to have that milestone there to kind of force things.
That's great. Yeah, I think we all learned a lot about AWS this week.
Yeah, I would say we're still not really there. There's still a lot of very low-hanging fruit that we wanted to get to, that we just couldn't for time reasons, because there's so much in the data and it's so rich.
Yeah.
So there's a lot of obvious things for next year that I'm really excited to hit the ground running and to look at, especially some more of the lab data. That was something that we used, just kind of scratched the surface of. We used a little bit of it, but we really want to incorporate more of that for next year.
Cool. Yeah, I think, I wanted to kind of probe kind of what your next steps are. Assuming you're continuing in the competition, what are you excited to kind of hit next? What's your next challenge?
We want to use other data sets, like publicly available data sets, I think would be very helpful. So I've heard other people maybe were using that a little bit for this phase, but I think next phase we'd really like to start bringing in that a lot more because we had so many challenges with the data that we were provided that we ended up just focusing so much on being able to ingest that and run it and train on it and everything. So I think that will really help us in the future.
Mm-hmm.
Yeah, I think we're really looking forward to spending a lot more time with the vitals waveforms. We started to look into that sort of in the latter half of phase 1. And we started to get promising results for, a patient state estimator based off of those waveforms. The nice thing about a lot of the vital signals is that they are shared between UMB and UPIT. So we did have a unified data set there. We can bring in additional data sets too. But we started to look at the ability to reconstruct missing waveforms. Got some promising results, but again, it was just something where we kind of ran out of time before the challenge. And now that we have a software framework that sort of works with that evaluation setup, I think really focusing on some of the models and algorithms will be a lot of fun.
Anyone else want to tease next steps or things you're looking forward to for next year?
I guess for us, we want to see what the change is going to be from DARPA's end in terms of the data set, what's going to be different about phase 2 than what we did in phase 1. But regardless, we had in the first phase we kind of processed the data without too much kind of paying attention to what they medically means. So we do have some medical experts on the team that we haven't leveraged, as much as perhaps we should have. So hopefully in the second phase, we will pay more attention to interpreting the data and trying to understand it better from a medical perspective before we feed it into our models.
Mm-hmm. Yeah, and going down that road, I think explainability is kind of what he's talking about a little bit. I think that's very important, and I would like to see that kind of included more, I think. Because obviously if you're a clinician, you're trying to use this as a decision support tool, you want to know why it's telling you to do this LSI, not just to do it. So
right.
Confidences maybe too, those sort of things, I think would be great.
Yeah, so now that we have a little bit more time, or the time's reset, we're also looking at, taking a little bit more boutique look at the failures. So have the clinicians, analyze the medical record and see if they can determine why the action was taken or why the algorithm was incorrect.
Mm-hmm. Interesting, yeah. So you're kind of incorporating that clinical expertise on your evaluation side or sort of the analysis side of the outcome of your algorithm.
But that's what we're going to attempt to do.
Yeah, that's great.
I'm not sure if that's going to work because we had some clinicians look at the data and they couldn't tell why that LSI was applied to that patient and not to the other patient. So I don't know.
I mean, you mentioned the explainability and the sort of usefulness. In what ways are you all kind of keeping in mind, like the human-machine teaming part of this? How does that inform your development now, even though you're not developing something that a human is using? That is sort of the long-term goal. Is that something that you're keeping in mind, and how does that kind of manifest in your work?
I think we're in some ways trying to do, we'd like to really pull out features that are difficult for humans to see or that aren't already clinically known, right? So I think that's part of why we're focused on the waveforms, is that it's something that's very hard for a clinician to, it's easy to show up and kind of guesstimate someone's age and, are their eyes open, things like this. Humans are already very good at that. Mm-hmm. So to take the machine and use it for things machines are good at, but that people are not necessarily good at, which is, quickly in real time, like what's the slope of that? Where's an inflection point? Those are things that machines can handle very well, but people can't. And so having something that's propping someone up from that side of it, I think would be really helpful.
Yeah, interesting, definitely. Any other, in terms of human-machine teaming, any other thoughts on how that's kind of informing your approach? Well, we certainly want to incentivize that in the future. So I'll come back to you with that question later in the challenge. Any advice for future participants in the DARPA Triage Challenge? Anything that you would tell yourself a year ago going into it?
For this particular challenge, being able to steadily make progress was sort of key, because this wasn't one you could just jump into at the end and make it work. Mm-hmm. And so having the checkpoint of the workshop and making sure to take advantage of that checkpoint and use that opportunity to see how you're doing was, I think, very helpful to our team. Mm-hmm.
I would totally agree with that, because I think we had a distinction of being the worst performance in the workshop.
We missed that superlative earlier. Thank you for bringing that up. Yeah. Yeah, I think the workshop was, it seemed like, yeah, we saw a lot of development advancement from the workshop to the evaluations. That was really fun to see on our side too.
I think if I could give myself advice a year ago, it would be to build in a lot more room for technical errors and AWS-related difficulties.
Mm-hmm. Yeah, part of the reality of working with health data is there are some extra hoops to go through, for sure. Any other advice from the people in the room or online?
Well, having a good evaluator is key, because the difference between the workshop is that we had now the evaluator that DARPA was using. Now, I'm not saying necessarily that the metrics are the best, but it really helps focus the, where you need to, do work. Whereas previously we were working with data that came from the EHR, but we weren't considering, for instance, the order that the data. So for instance, if a lab result comes in at, after half an hour, but you need the LSI at, intervention stage 0, we weren't considering that in our first attempt. So the evaluator really helped us, because we realized that this time dependence.
Thanks. Yeah, that makes sense. Yeah, I think there's been.
So I'm not sure in the future, are you going to release these kind of evaluators sooner? Or we're going to have to create our own?
Yeah, we plan to continue supporting the teams with having the tools they need to use the evaluation we've designed. It'll look more like tweaking what you already have rather than a totally new package. But yeah, for sure. I think that was something we definitely wanted to get out to you all. Yeah, what other tools have you? Oh yeah, please go ahead. Yeah.
Yeah, I think building on that, the evaluator is a great tool that we used often. I think also just upfront planning and designing out unit tests. That went a long way for our team. We were able to simulate, for example, like signal flatlines, data dropouts, these types of things that otherwise would have caused errors in some of our signature calculations. And when you have this size of data set, if you don't do that, you might make it through several hundred patients and then all of a sudden have an unhandled exception or something, a couple hours in. So if you can upfront plan for that and test for that on these smaller scales, you'll save yourself, I think, a lot of time in the long run.
Yeah, I think something that we saw on the evaluation side was the the danger of making any assumption about the data before you see it. And so, yeah, there's a lot of defensive maneuvers needed to, and I think that's a realistic part of any sort of deployed system to be able to handle those cases. But yeah, great advice, yeah. So, so Sam mentioned the evaluator, but I'm sure that you all had your own kind of tooling that you developed, either to understand the data or to understand your algorithm performance. I'm curious to hear about any tooling you developed, like kind of how much time you spent on that versus using those tools. Did anybody come up with their own evaluator before we released it, or are there other ways of measuring accuracy that correlate with how we're evaluating teams, but maybe aren't exactly what we're using?
Yeah, we have our own evaluator. We basically, before the release of the other one, of the official one, we have our own evaluator that runs locally, so we can run it much faster without doing the communications portion. So we spent a lot of time working on that, and I think that's probably why we got the highest accuracy, and also maybe a little bit of our downfall for this phase, because we were very focused on accuracy, and obviously that went really well for our team, but maybe not as focused as much on the timing aspect. And that was something that was probably a little masked by using our own evaluator. So that's something to keep in mind for phase 2.
Yeah, that sounds great.
Yeah, we built our own evaluator as well. And so after we got our workshop data back, we saw one that we didn't think that was the right score for us. And so we ran it through our evaluator, and our evaluator said, yeah, your evaluator was wrong. But then we looked for a little while longer and found that there was a bug in ours. So.
Oh, phew. Good check. Thank you. I appreciate that.
We're that far away from sending the email, but.
That's great. Yeah.
Yeah, we had our own evaluator too, and one thing we were looking at is at admission, how that scoring worked. And we kind of wanted to score it a little bit differently because maybe the algorithm was correct in predicting it at admission, but it counted differently with the way the official scoring was. So we just, in some ways, we just wanted our own metrics to just see if it's working the way we intended versus just the official score, I guess, as well.
Yeah, I think that's wise, because I mean the metrics are going to evolve with the challenge as well. So if you have your kind of other ways of measuring performance, that can hopefully generalize to the future too. Yeah. You mentioned, was anybody in the online about to unmute? Yeah. Hey, Kelly.
Oh yeah, I was just going to add that we set up our own evaluator before the workshop. And we found it really helpful to, do the whole data transmit pipeline. I think the only difference between ours and the one that was released later was ours didn't have to run in a container, which made it a little easier for, like me and other teammates who aren't as familiar with that process. But, just the timing, especially because we had, classifiers running in different processes in parallel, and just how that all translates to a prediction when we want to predict, especially given that a false alarm for a single segment is held over an entire case. We just found, sort of testing in that online environment where you get predictions in at different times was really useful, and I think something that we'll continue to look for in the tools going forward.
Nice. Yeah, I do want to ask about, evolving inference over time is, I think, really challenging, and sort of the accumulation of evidence. And we provide, it's not only kind of within a sort of like the same kind of data realm, but you also have, so you have data from the pre-hospital window before patients are admitted to the hospital, and then following those patients through the first few hours of care in the hospital. In what ways did you incorporate that sort of evolution in your approach, or did you find it was more useful to just focus on kind of the recent past or the last 5, 15 minutes of data?
Well, that's what we found was the most useful, because it kind of goes back to one of the surprises, or what we didn't anticipate, was that the majority of the LSIs are front-loaded early in time in the case. And when we initially come up with our plan, we were anticipating maybe longer time series of data to be available. So when we tried to make models that use longer amounts of data, there were just so few events that you could use that for that we didn't really end up doing that.
Mm-hmm. We had the same experience. We tried both approaches, building up state and using past information versus just using those slices. And the correlation was always higher in the slices, and I was very frustrated by that, because it seems like that past information absolutely should apply and help, but we just couldn't get to that point where it did.
Yeah, I'll be curious to see how it answers to that particular question, kind of if it's a matter of time and initially looking at the recent past makes the most sense, but it's really about figuring out where that signal is.
Yeah, so we kept hold of the past and built up state, but it was very challenging. We spent a lot of time working on how to summarize that past state and get that past state down, because otherwise, you do get very overwhelmed by there's sort of too much data and it's very hard to make inferences. So that we focused a lot of our efforts on what information to keep from the past and what was really giving us the strongest signal and what information to drop. Mm-hmm. So it took a long time to be able to get to a point where keeping the past was more useful in the same way.
But you got there in this year?
Yes, yeah.
Ah, that's great, yeah. Any other takeaways on inference over time, temporal processing?
We honestly didn't spend all that much time differentiating the old data from the new data. And we're kind of surprised that it didn't make too much difference for us. That being said, we didn't get to, like a lot of teams have said, we didn't have a lot of time to play with these things.
Yeah. In what ways, oh, sorry, Kelly, I was gonna go ahead, yeah.
No worries. Sorry, I always wait till last minute. I don't know if we have a takeaway per se, but another thing we found sort of challenging and we'd like to investigate more is just, when there are multiple LSIs performed, but of the same type of LSI, just at later times, that wasn't necessarily distinguished in this evaluation. But I think there is, there's information there about, if a patient has received, blood products already, how does that impact things going forward? And, again, we did see on the slice level or just aggregating over the first handful of segments tended to perform pretty well. But, I think there's a lot there. They've received certain medications and, that's changing the vital signs going forward. How do we best incorporate that into the model in a condensed format? And so that's just something, not necessarily a takeaway, just another challenge that we had.
Yeah, great, thank you. I was curious if there, so we provided, you had information about which patients received which LSIs over time, and that was that was how we evaluated models that were submitted. But were there ways in which you kind of grouped cases or kind of partitioned out the data set to either learn from it or kind of test whether to kind of treat different subpopulations differently or use different techniques on different subpopulations?
So I can say we split out, and I don't know how other people did it, but we have, I think there are 12 LSIs, and we have 12 models running concurrently that are separate. So we have a model trained to predict whether or not you should get blood products that is, knows about whether or not you've received crystalloid products, but is not trying to predict that at the same time. So we sort of treated each LSI group as its own binary predictor. We thought about trying to get them more intertwined together, but that wasn't something we had time for, and we found that it worked pretty well to sort of treat each LSI kind of as a distinct predictor. So we didn't separate the patient populations, but we did really separate the LSI populations and think of them each as their own distinct thing.
Yeah, interesting. Yeah, I'm curious how other teams, I think there's a spectrum of one model to rule them all versus, an ensemble of models or fusing models together. How did the other, I'm curious to hear about other approaches used.
Yeah, so we tried with a single, basically multi-class, try to simulate it as a multi-class neural network, where there's one neural network we transform the data, and that transformation happens on the and the segmented data. So when you have segments, and we tried with a multi-class neural network, and personally I was surprised that it performs much worse, because for whatever reason the data is not sufficient enough or not distinct enough to be for that neural network. At least the one we tried, but we didn't have more time. But if I did have more time, I'd like to try a transformer-based model, which would be a lot more complicated than what we did try. We tried a relatively large, but not really large model trying to predict multiple classes, and it was sub-performing. So the similar approach of creating one model per LSI was performing better than this bigger model.
Our team, we had one single model. We didn't try any other way, so I can't tell you with some of our approaches, what that difference would look like. 'Cause I'm sure there's a lot of pieces that go into the pre-processing and the signature extraction that might influence, is one model better than 12? But
we ended up having multiple models. We're based off of the time in the case. So especially for the EHR data, there was one looking primarily at start of case information along with vital signs and trends, and then one for at admission or at certain events. And we found that was good. There was, again, another challenge just in figuring out how to aggregate those into a final prediction, and when we actually wanted to predict, depending on where we were in the case. Yeah, we found that worked pretty well. We'd like to try to unify those going forward, though.
We had two models, one for each emergency center, and haven't tried anything else, so really can't speak to what else would work better.
We, in the data, we grouped the LSIs with these kind of overarching groups. So you found, multiple specific LSIs that we were treating as a single kind of category. Did any of you all use the specific LSI, or were you mostly focused on the groups that we were kind of evaluating models on for this first year?
We split them into the LSI descriptions in some cases, just because, I think in some cases there could be different symptoms that might appear in the vital signs, where they might be treated differently, medication-wise. So yeah, we tried to create classifiers that predicted description and then from there aggregate into the 12 groups.
Anyone take another approach?
We found like a lot of the LSIs are just so sparse that grouping them actually helped us learn things about it. But and I actually didn't spend too much time looking at them individually, but I think both are quite interesting.
We only tried the description for crystalloids just to try to get our head around, get the algorithm working for why the crystalloids, like why some patients were given or not, because there's different types of crystalloids, but we didn't make much progress, so we didn't do that.
Anybody in the room?
We stuck with the groupings.
You stuck with the groups, okay.
Yeah.
Great.
We didn't have time to do much else.
Yeah.
Totally.
Yeah, I think it'll be interesting now that we have a bigger set of data, assuming that this competition data then is released for training in the next phase. Because we ran into kind of the same issue that if you're looking at doing a more data-driven method, a lot of the sort of subcategory LSIs, there just wasn't enough data there for us to leverage some of the statistical methods on.
Yeah, definitely. Yeah,
Some of them are just one or two. I mean, when we did an analysis, some of them are, if you include the description, there's only one or two examples. There's no way you could learn that. Because it's either going to be in your test or training, so it's like.
Yeah, definitely. There's it's a mix of possible and impossible in some aspects, and I think a lot of this year has been learning kind of where the edge of the possible is. So yeah, we're excited to take that into next year too.
It'd be interesting too along those lines to include kind of the severity or the like the result of getting it right versus wrong, because some of these LSIs, I mean, like crystalloid products, you just give it, it's probably not going to kill you or make it that much better, but some of these you really have to get right. So, and like the importance of it from a clinical setting might be interesting to look at as well. And that's part of them, that's probably why there are only like one or two of some of these, like, you know.
Yeah, and I think that applies to like limited resources too, where, you know, especially like blood products, you know, reserving those for the people who need it most, that sort of thing, yeah.
Or you put someone on a ventilator when they don't need to be, that's pretty bad.
Yeah,
you know? Or if you don't ventilate them, that's really bad too, so yeah.
Totally.
Right.
Yeah, I think that's something that a lot of us are interested in, is that just given the breakdown of the data set as is and the metrics for this one, we ended up putting probably more importance on things like crystalloid products or just no prediction than maybe we would want in terms of like clinical outcomes for people, just because those are obviously, they're given to lots of people, so they're very represented, but they're maybe not the most important intervention that you're concerned about if you're coming into the trauma center.
Yeah. Yeah, I think that's great. I think I'm curious, you know, the RITMO data set that's provided for this challenge, I think will have, you know, applications beyond DARPA Triage Challenge. What other kind of questions are coming up in your mind, or things that you would love to kind of answer, or how would you like to work? How do you think this RITMO data will be useful kind of in the future, maybe beyond what the questions we're currently asking with this first year of the DARPA Triage Challenge?
I think definitely, at least for us, and we're signals people, so we're always sort of drawn to that a little bit more, but we worked some with some of the synthetic signals, and having access to the real signals, including all the sort of real messiness that comes with real signals, was so helpful for us. And I think being able to have this data set, not of sort of like, here's what a PPG looks like when we have a healthy person and they're sitting in a chair, not moving, and oops, we kind of pressed the button wrong, and so it was like weird, messed up at the beginning, we'll retake it. You know, having the data in the way where you're getting the signal as it really comes was really great to be able to have that data, because they do look very different, even from, you know, kind of the best types of synthetic data, just because they have so many more artifacts, and you're getting people that are, you know, experiencing, obviously, hopefully, events that you're not experiencing every day. So being able to have that real signal, I think, is so hugely important.
Yeah, I think this is a common theme across all of the competitions, where the messiness of the real world kind of throws a wrench in a lot of the sort of controlled research out there. And so I think I think it'll be really neat to see how people kind of work around that, or learn from that. I think it will hopefully result in, you know, a step towards sort of deployment of these types of systems. Yeah. Any other things about the, you know, the data that people are excited about, or, you know, once you actually got the data, you know, maybe, you know, outside of the challenge, or other kind of use cases you can imagine?
I don't know, I think it's challenging because trauma care actually evolves pretty quickly. And I think like the crystalloid was a great example of that. And then, and there are also things like needle decompressions that were very common 5-10 years ago that are now. So it's one of the things I find very interesting is like, any model you make has to be constantly able to evolve, because the things we're trying to capture are evolving very quickly. And one thing that occurs to me too, talking about metrics is, and I think this gets a little back to the clinician tool interaction, is, you know, instead of having binary predictions, having the continuous predictions, because I'm an emergency medicine doctor, and, you know, things are often not black and white, and, you know, telling me that someone, instead of like a binary, telling me, you know, someone has a 40% chance of needing a chest tube, actually gives me a lot of information and can kind of change what I'm focusing on. So it might be something to consider going forward.
Yeah, I totally agree. I think it gets to that question of human-machine interaction, and also, you know, translating machine information to human information for decision making. Yeah, I think that's an example that we definitely want to, you know, incorporate as we move forward. Yeah.
Yeah, I think going along with that, in terms of like human-machine teaming, the way we had the scoring set for phase 1 at least, you know, getting kind of a transient signal of, hey, this person might need blood products, you know, and that signal happens once, that looks the same, and maybe that's wrong. That looks the same as a machine that's saying every 5 minutes, like, wow, this person really needs blood products, this person really needs blood products. So one of the things we found in our training is that to account for that, we were very concerned about false positives. So we were really beating down those false positives, and that's what got us that really high accuracy. But in terms of a clinician maybe using a tool, it might be more useful for them to have things pop up a little bit more often with less of a false accuracy, or to have things where you can be like, oh, it's sort of thinking blood products, maybe I'll keep that in my mind, I'll keep an eye on that. And then, you know, maybe that goes away and you're like, oh, okay, maybe not. is really different from something that's kind of screaming at you like blood products
Yeah.
for this person.
Yeah. I think that, we talked earlier about the sort of temporal processing and accumulation of evidence over time for machines, but I think you could make the same, or, I think it's a similar problem of how to kind of communicate that to a person who's accumulating over time with their brain,
Yeah.
And so, yeah, I think that's a great point.
That's always a hard balance for things like this, is to, you want to be as accurate as possible, but also catch everything. And something that's wrong too often, people will start discarding. But something that's a little too cautious, they're also going to start discarding because it didn't, pick up enough times.
Yes. Yeah. I think the end goal is to have something that could be useful to a clinician, and so we're definitely incorporating all these things as we make the challenge more challenging.
One interesting thing as well is in our data, it's not necessarily true that it was the right thing to do, right? It's just what happened. So we're interested in using synthetic data and using pulse physiology engine, because that way we can apply the insults so we know what the problem is, so we know what the solution should be, and maybe that's a cool way to train it as well, instead of just what happened that may or may not have been correct. Like, we know what the gold standard correct way of doing things is. So it's another.
Yeah, that's interesting. Yeah, I mean, I think we have a couple more minutes, but yeah, I'm curious. I've heard mention of external data sets, synthetic data. Are there, I guess, any other thoughts about how you're kind of incorporating, I guess, expert knowledge, any other outside resources you're kind of pulling in your development, in your solutions? Or maybe shifting gears a little. In what ways have you all kind of learned from each other over the past year? Has there been any? How is the DTC community growing over the past year, and how has that kind of helped in your path forward?
Well, I'm not sure directly if there'll be any help. I mean, because it's a competition, right? So we're not going to directly help each other, right?
Yeah, most of the communication is focused on technical issues, people running into the same problems with AWS and how they got around them.
Yeah. Well, that's great. Yeah, I think that. I'm sure that there's some shared commiseration, at least.
Yeah, the forums are helpful for sure for that.
Good, yeah.
Yeah, the forum's definitely helpful. I think also maybe having, this is really only our second checkpoint where we've ever had our models evaluated sort of against each other or in a collective. So as we do more workshops and more things like that, I think that'll be really helpful for trying to get, because something we had and that I've heard other people did, right, is have a little bit of an internal competition between models. But you only have so much time, so you can really only make so many, and they're only so good because you don't want to put lots of time into making 7 really great models. That's not going to be a good use of your time. So this is really kind of the first time that we know how our models have done relative to other things, as opposed to just relative to, I think that's why we got high accuracy in our model, is that was one of the things that we were able to, be objective about was, can we increase this accuracy? But one of the things that we were really in the dark about was, I don't know, it seems kind of fast to us, but how fast can you run one of these models, right? And this has been really helpful, seeing other people's models and their speed to be like, okay, that's something we can push a lot more on.
Yeah. Kelly, were you about to say something?
Yeah, I was just going to say that I think, the discussion after the workshop and this discussion, I found useful just because, yeah, like it's been said, we don't have the time to train all of these different models. And so seeing what approaches other people are taking, whether it's the same as us or whether it's different, is interesting. And just those, sharing those findings, I think is helpful as we go forward and try to figure out, with the new challenges that'll come with phase 2, what we might want to change with our approach or what we kind of want to keep the same.
Yeah. Yeah, that's great. Yeah, I think we're all looking forward to the workshop for this next year where all the teams have now had a chance to kind of, get the wheels turning, and I think it should be really interesting to see where things go in the next year. So I think with that, I just want to thank everyone for being here. This was really interesting discussion, and we look forward to next year. So thank you.
Just a quick question.
That concludes our morning session. Please enjoy a break for lunch and join us back here at 1 p.m. Eastern. All virtual competition panelists, please meet at the side stage. Please welcome our DARPA Triage Challenge virtual competition team leads and panel moderator, Wes Milks.
Good afternoon, and thank you for actually coming back after lunch. As the voice in this guy said, my name is Wes Milks. I'm with Applied Research Associates, and we are developing the test bed for the virtual challenge. To start with, I'd like each of you to introduce yourself, tell us which team you represent, your favorite color, and what was your approach to assembling your team. And be aware that your choice of favorite color does affect your phase 2 score.
Okay.
Okay.
Okay, my name is Wolfgang Schwab. I'm team lead of the team Flying Fishes. And yeah, favorite color, okay, let's take blue. Yeah, so what else?
What was your approach to assembling your team? As
Okay.
far as technologies, skill sets you're looking for?
Okay, I was looking for people that fulfill all the requirements that we need, and I found all of them in my family.
Okay.
So I'm an engineer for aerospace and aeronautics. I have a mathematicians with me, with my brother, and 2 of my sons are students of mechatronics and students of physics. So I think this is the good experience that we need for this challenge.
Good, thank you. Next.
Hi, my name is Amandeep, and I'm from Team TTT. And favorite color, I was going to say blue, he stole it.
You don't have to be unique, you can
no,
reuse.
Since it affects the score, I'm going to choose the yellow for the staff. Maybe that earns me some points there.
He gets a star.
But my criterion mostly was accessibility. I've recently moved to the other part of the country, so I don't have access to the teams or the people I've worked with before in terms of research and such. So currently it's just me, but hopefully I'll expand soon.
Okay. You assembled yourself well.
Yeah, I did.
Next.
My name's Kevin Knadler. I'm from Coordinated Robotics. I'm going to go with blue. I think that's a good color, whether it gets a star or not. And so for the simulation, it was just me. So it was pretty easy to assemble it.
Okay.
Dave Canis, Engineer and Dynamics. Favorite color is black, with just a hint of red. You'll notice that reflected the logo. The way we assembled my team is any other challenge. I believe that engineering is actually a people problem. So my first 2 hires were a sociologist and a psychologist, which are weird hires for an engineering team. But I think that extra perspective really makes the product that actually matters.
Now that the year 1 is over, do you think those are good choices? And if so, kind of why? What did they bring that a typical engineer wouldn't?
So for the virtual, it was not as important as systems, but for systems especially, and virtual to some extent, we really started from looking at what the end user would use out in the field, and we tried to roll that back to build our requirements. And the kind of people-focused perspective really helped to figure out what we should be working on at any given phase.
Okay, good. And online? Anybody want to volunteer to go first?
I can go. My name is František Brabec. I'm with Team Robotica. And our team consists of experts in triage and emergency room, medical care, as well as robotics and general purpose computer science. I'm gonna have to say that my favorite color is blue on account of the shirt. We also participate in the in the data challenge. So we kind of build all-purpose team across these tracks without necessarily knowing which expertise will be most applicable in which track.
Okay, thank you. Go ahead.
Yeah, so hello guys, I'm Chirag Sehgal and I'm the part of Team USDTU. We also participated in both of the challenges, systems and virtual. Going on with my favorite color, I'll go with pink, going differently than others. And as per the criteria on which we selected our team was, I think we are just a bunch of different students from different disciplines, from computer science, engineering, physics, and like the criteria was majorly interest in interest and experience with deep learning, machine learning, and a background of medical knowledge and triaging. So that's what we went with, and that's how we gathered our team together.
Okay, thank you. All right, without giving away your secret sauce, can you share a bit about your strategy? Any specific algorithms or tools you used that were particularly useful? Open to anybody.
We used a simulator. We used YOLO V8 from Ultralytics for doing a lot of the YOLO type stuff and training the images on that. Trying to think of other tools that we used that were specific. One thing that was interesting, it's somewhat tool-wise, used a lot more Python on this particular contest than I had in the past. I've tried to focus on C++ a lot in the past and ended up using almost all Python this time around.
What was the reason for focusing more on Python?
It's very quick to get written and tested, and so given some of the time constraints on this one, that was one of the reasons. The other reasons is that the way YOLO and Ultralytics is set up, they have a lot more examples in Python, and so there are a lot of smaller things that could be done and put together in that way.
Okay, thank you.
We had, sorry.
Go ahead.
We had a similar idea, starting with YOLO, fine-tuning based on some of the data we had, and Python again, just for the ease and quickness of getting something going quick.
Anybody online want to share anything about your strategy or tools?
Yeah, so
go ahead.
The base strategy was to go ahead with YOLO V8, but I think particularly for us, we really found difficulties in generalizing YOLO to like some sort of context, or even for the problem statement of trauma identification. We particularly felt that particular strategy was very domain driven, or since we had very less data, so it was very difficult to generalize in that field. So for that particular manner, we went ahead with vision transformers and for different pose estimations, and then moved on to strategies that were more contrastive learning based and transfer to particular domains of these injuries, because I think the major challenge that we particularly faced was the amount of data that we had on which we had to train our models and algorithms. So yes, we majorly went ahead with approaches that would generalize the concept and generalize the domain for whatever we were assessing on. Again, going back to the example of trauma for say. So yeah, we preferred algorithms that would generalize, would be easy to generalize the domain and that were proven to work in zero-shot settings. So that is what we went ahead with.
Thank you.
We have also used YOLO for the detection of individual components within the image stream, and we used another module to help us analyze the audio that was being broadcast, and so far it's all tied with Python as well. But I would imagine going forward, if there is a lot more a real-time data, large amounts of data to process, coming from LiDARs and radars and things like that, then those would probably be done in C++.
Okay, thank you. From a strategy standpoint, could be inferring too much looking at your score reports, but it seemed like some of you focused more on some score factors than others. Others seem to be rather static throughout most of your assessments. Is that accurate? Did it just turn out that way? You were working on doing the assessment and it just happened to come up the same in almost all cases, or was that an intentional part of your strategy?
So we decided to take the strategy of going faster We wanted to be able to do the heart rate and respiration in the short period of time. It turned out not to work very well, and so unless there was a reason to, we guessed a static value. I think I heard Robotica got the prize for that. But we were focused on that and then focused our efforts on the other areas of the contest.
Okay.
And we had much the similar approach where we focused on speed. Our focus was, hey, we want to make sure we try to do some sort of basic triage on everyone rather than doing extremely advanced triage on a fewer number of people. So we also focused on speed. We also focused on, getting heart rate and respiration was extremely challenging in a short time span. The longer you can look at data and record it, the much more accurate you get. But we were really struggling to come up with a fast, good value.
Okay.
Yeah, for me it was similar in the sense that I did have some static values, but my focus was more on hemorrhage and respiratory distress. And the heart rate and respiration rate were the hardest to be accurate. So my idea was to have some guards when the lower and the upper guards where the values are completely off the charts. If it's in that range, it's off the charts, then it goes to a static value. Otherwise, within a reasonable range, it uses the value that the code predicted.
Okay. Anybody else want to share?
Yeah, we had a similar approach. Where we could, we provided our analysis of data that's coming from our analysis, but we had a static fallback values, so where we were unable to determine something.
Okay. What surprised you the most during the challenge event 1? Could be either pleasant or unpleasant surprise.
Lots of changes going on, but to me it was, initially when I was working on it, I was very focused on trying to figure out the navigation of the system itself. And then I was pleasantly surprised that don't have to worry about that.
For year 1. The next year you will.
Yeah.
For us, it was a technical issue. So we'd run the Docker image locally. It's got to be probably 30, 40, 50 times. It was beautifully run. And then when we switched over to our actual submission, we got a lovely email from them going, hey, it's not running. And we were like, okay, so why? Did a bunch of testing last minute. And we were like, okay, so we switched from, we had just been shoving just tons of data using shared memory from to the GPU. And that changed in the actual challenge to disable that shared memory, or rather to limit to a much smaller amount. We were able to figure it out, but definitely we expected the Docker image to be consistent across time.
Okay. Probably have to follow up on that one. Anyone else? Pleasant, unpleasant surprises?
Yeah, so for us, I feel like the results, the recent report that was shared, one thing what happened particularly for our submission, I think did not happen for others, was that for some amount of a considerable amount of casualties that we assessed, our reports were not assessed or published, they were not evaluated properly, because I think what approach we started out with was instead others trying to have a faster and a shorter run with minimum data collected. I think we took an average amount to collect as much as data we could with completing the evaluation of all casualties. So after that, what we were planning to do was we were planning to process all of these data in a sequential manner, in a round robin manner or whatsoever. So everything was happening in the backend, and whenever a process gets finished, a particular report for a particular a niche vital gets published later. So for example, if we've collected the data for casualty 1, we were planning that we'll run its process in the background, and whenever we get sufficient time, we'll report it. So yes, initially we were not very concerned with reporting it as fast as we could, but we tried to be more accurate and use heavier resources and maybe batch process for multiple casualties. So one surprise that was for us was that a lot of our reports were they were not evaluated. So when the score came only a few of the values were evaluated in the scorekeeper. So I think that was a surprise, and we'd like to explore that on why that particular problem happened. Because so that was like a surprise for us. So we'd like to look into it more on why only a few of the reports, like why only a few of parameters were like submitted and evaluated by the scorekeeper.
Okay, yeah, that was definitely not intentional, so we'll follow up and see if we can figure out what happened. Anyone else on pleasant, unpleasant surprises?
I mean, one thing I would say is it was a little surprising that we were supposed to evaluate on certain properties or find out if certain properties occurred, a limb missing or something like that, and many of them were barely represented, if at all, in the sample victim set that we were given. So it was hard to kind of design the algorithms to detect some of these things without actually having at least one example of that within the test set or the development set we got.
Okay. Let's see, what did you learn in the workshop, and what changes did you make from that in your final implementation?
In the workshops, there was a good idea that we could reuse the simulation for multiple runs. Unfortunately, this did not make it through in the simulation. So this would be a nice idea to have easier testing, because our testing is always running the Docker until the simulation ends, or we break it, and then we have to restart all the systems. And that's not so easy for testing. So from the workshop, I thought this option will be possible, but in the later stages, I did not see it anymore.
Okay.
So I would really appreciate it if it could be done, but if not, it's out.
Okay. Anyone else?
I'll say that the workshop was very beneficial. It let us realize that we were going completely the wrong direction. So we ended up scrapping it completely and starting a brand new model, which worked a lot better. So the workshop was helpful because we were able to realize that we were not going in the right direction and something needed to change.
Okay.
It would have been very easy to hit the end zone without actually realizing that.
Can you talk a little bit more about what approach you were taking and how it changed?
We were just measuring things in a way that wasn't producing reliable and consistent results. And at the same token, it was extremely inefficient, just using tons of memory, tons of bandwidth. And so we started again focused on speed and efficiency. But I think prior to the workshop one event, we thought that we were doing pretty okay.
Okay. What did you find most difficult?
Heart rate detection. So for a person that's standing still, it's possible. But the moving casualties, that's a challenge.
Okay.
And this was a challenge for us that was very high.
Okay, fair enough.
Yeah, I agree with that. The moving and the lighting changes on the face make it very difficult to measure the heart rate remotely.
Okay, so you're saying that the virtual simulation was realistic to an actual case?
It's also a problem.
Which is still hard.
Yep.
Okay. Anybody else?
Yeah, one thing we struggled with was, some of the casualties were, in quite bright sun, and so the nuances in the temperature on their bodies were kind of lost in I think the sun could have been also the blaze from the train. So for some of these victims, the infrared channel was pretty useless.
Okay.
So like for us, I think the most challenging part was like the first initial data set that was released for the virtual competition, and then the Docker image and the rendering of the casualties, the second on which we had to evaluate and actually test our algorithms. I felt that there was a difference between the quality of rendering and the data that was being transferred to this simulation. I felt like there was we stepped down in terms of the quality of data. So some of our approaches that we had developed prior to that Docker release, a lot of them were rendered useless. So I think one difficulty was to work the algorithms with the rendering quality. So yeah, that was the difficulty that we faced.
Okay, good.
Can we ask you a question too? What was the most
difficult
part for your team in terms of getting this going?
The hardest part in the beginning was figuring out how are we going to make these virtual avatars actually have a heart rate and respiration. Respiration, I mean, we can assign it and we can do animation that makes them breathe, but tying that in with actual physiology data from BioGears was a little challenge. But the heart rate was the harder one. And to be honest, we were pleasantly surprised when it kind of worked the first time that we overlaid the physiology data through a off-the-shelf RPPG algorithm at the virtual data stream, and it actually worked. We could pick up a heart rate from a virtual character when the tools we were using had never seen a virtual video stream before. So that, and then aside from that, is just one of the hard things we ran into is just the compute and memory power of having, in this case, 30 casualties out there, and how do we kind of break that up so they're not all in the scene and not all taking up CPU power and everything. So kind of doing that load balancing to make it all work, and which is going to get harder as we move along. We'll have to come up with some new strategies. Good question. For those of you that participated in both the systems and the virtual challenge, what did you learn from one that helped you in the other, and it kind of go in both directions? Would you learn from virtual that helped in systems, or would you learn from systems that helped in virtual?
For me, the virtual got me started quicker in terms of the algorithms that I was planning on using in the systems. So it got me a virtual platform to actually test what my systems were going to do. Instead of just starting on bench testing, I had a system to test already. So.
Okay, good.
And I'm also in both. We were very excited about the possibility of being able to have, an on-demand test bed, representative of a real environment. For phase one, we found that the two were close enough to see a lot of potential, but that it was fairly challenging to use the results from one to the other. The virtual still feels more like a lab environment where things just kind of just work the way you would expect. And then you go to the real world and it triggers off of the grass waving in the breeze. And
okay.
Very excited about phase two because, like I said, on-demand test bed.
Good. That was kind of the intent, is that there'd be some kind of back and forth of being able to use the virtual to create data and use it as kind of a test bed for your real world version. Right. Kind of hit on this already, but I'll ask anyway. What are your thoughts about detecting the health state, particularly the heart rate and respiration from virtual data streams? Is there, you talk about the challenges, is there ways we could make that more doable without making it unrealistic?
Just have them hold still, constant lighting.
Put hands on your shoulders.
I think the simulation's realistic in that manner. I don't know that it's going to be easier and be realistic. It can be one or the other, it seems.
Okay.
The one thing I would say was, it was really good, but it might be worth checking which, I know you chose some RPG algorithms to check against, but there's some which are more biased towards some values than the others. Because for the same data set, if you use even the classical ones, they will give slightly different answers. There's a couple which are the most basic ones. They are slightly on the lower end. The others agree better. So depending on which one you validated against, the actual, whatever we end up using may or may not match it. So it might be worth, I don't know, you probably already did, I'm not sure, but it might be worth checking against a gamut of them.
We used, I think it was about 5 or 6 different ones.
Okay.
I don't have the list in front of me of what they were, but we did use more than one.
Okay, then, yeah.
Other thoughts? Okay. From a lessons learned perspective, was there anything you tried that did not work as you expected? You already kind of mentioned one of those. Anybody else have something where you tried it and thought it was going to work and you end up having to kind of scrap it and redesign?
Respirations.
I think,
Oh, go ahead.
Go ahead.
yeah, sure. So I think for us, I feel that one thing that did not definitely work was trying to do it all in pieces. So like for the next phase, I think one lesson that we've definitely learned is to try integrate it as a whole rather than reporting values later and then waiting for it to be assessed. I think one approach that we'll definitely go ahead with is try to integrate it all in some one sort of system so that we're definite that our value that we're evaluating, it does get reported. So one thing we definitely learned a lesson on that.
Well, I learned to get the stuff I procrastinate about, like making sure this image works with the system or the rules, to do that first.
Okay. If you were going to restart phase 1 and do it again, what would you do differently?
I already said it. I'm going to do the clerical work first.
Because of the limited time at the end, our architecture is not really ideal anymore. So I would restructure the architecture and how we split the different tasks in the different engines and do it more split and more modular.
Okay.
I'd spent a lot of time working on the heart rate and respiration at the beginning, and that ended up not being significantly helpful in the end. So that time could have been spent on other things.
Okay.
And I would echo that as well. We probably spent half of our total development time on respirations and heart rate. And I tried a bunch of like really cool concepts that I could find a paper on, but you did that too. But those really advanced techniques are well suited towards laboratory environments. They're suited towards 1 to 3 centimeters. They're not well suited towards anything out in the real world at this moment in time. So I wish I had used that development time for the more solvable problems.
Okay. Any thoughts from the crew online?
I mean, for us, I don't know that, I would do that necessarily if I started from scratch, but, what I could consider was spend more time on training our own data rather than using, external pre-trained sets, and maybe that would give us better results in detecting what we needed to detect.
Okay. Going into phase 2, we're planning to make some changes in terms of things like some of the casualties will be partially obscured, buried by rubble or buried perhaps by other casualties, different environments, a couple new injury states. What are your thoughts on what you might do differently moving into phase 2? Or have you not had those yet?
I'd like to focus more on correlating to bring a more holistic model approach than more segregated models for each of the detection things. So I think there is something to be gained there to have the correlations and bring a more holistic approach.
Okay.
I want to have an iterative code base where my systems and virtual are actually connected and talking and learning from each other instead of 2 separate code bases with 2 separate lessons learned.
Okay.
That would be good.
All right.
Right. Online, any thoughts about what you're going to do different for phase 2?
Yeah, I think with new things being introduced and new injury states, we'd like to focus more on getting and like trying to get more and more with data so that we can actually feed our model to learn what actual state is. Like one problem that we currently face was, I think, the trying to split it and then at the same time trying to add more and more data so that it actually recognizes what it actually has to learn. So we'd like to curate more and more data set. For that, I think we'd be working on transferring from the real world domain, trying to work on domain transfers so that we can actually deploy a model that is pre-trained on a larger data set, maybe from the real world, and then like try to shift it towards a more virtual domain so that despite it being working on the real world, it also works on the domain that we're currently working in, the virtual competition, that is the simulation. So that is something that we'd like to focus on.
Okay.
Yeah, for us, I guess we will need to see what changes in going into phase 2. Obviously, we know that there's going to be our own driving, so that's a new factor. But in terms of what we would do differently, you mentioned obscure casualties. You know, we will need to see how much it affects our algorithms and see what we need to change most urgently, I guess, going forward.
Okay. Were there any sensor streams that you hoped would have been in the virtual testbed that weren't there? We had the video, audio, some LiDAR, although I'll admit it's not as robust as it's going to be next year, and also a little bit of radar. Are there other sensor streams that you guys would be looking for to include in future phases?
So the 2 sensor streams I think would be interesting would be depth camera. And the other one's not a sensor stream per se, but interactive audio. You know, it was a fixed file, and something that has more interactivity would be interesting.
Right. Okay. Yeah, that is on the roadmap for next year.
Yeah, I definitely want to flesh out more of the radar. We didn't use that as well as we could have, but a lot of potential there.
Okay. One of the things you're going to have to do different in phase 2 is, in phase 1, we gave you the waypoints which were the casualty locations. For phase 2, you're not getting that. You'll get a map of the area with no casualties in it. Any thoughts on how you'll search the area to see where the casualties are? Without, again, giving away your secret sauce.
I think there are multiple packages available to doing such tasks. So, I'm more afraid about the multiple robots and the coordination of the multiple robots, because this could be really an interesting and important task to solve this in a very good way, to get optimal usage of the time.
Yeah, autonomy and kind of inter-agent communication is at the top of our list of things to do for phase 2. Any other thoughts about searching the battlefield to find, or the play box, to find the casualties before you start going out and doing the assessments?
I guess my immediate thought would be, you know, you said we would have the map, so maybe identify the areas that seems easier to traverse and areas that seem challenging to traverse, and perhaps focus on the areas that seem to be easy first, so that, you know, the robot doesn't get stuck somewhere right away.
Okay. You will be able to use multiple agents in phase 2, up to 5. Do you guys have any thoughts of whether you'll max it out and do all 5, do 2, stick with 1?
I think all 5, why not?
5.
5.
Virtual robots are a lot easier to keep running than physical ones.
Yeah. The batteries last longer for now, until we put that in.
Are we going to have a choice, or are all 5 expected to be the same?
You'll have some choice, yes. Not necessarily all the choice in the world, but there'll be some. Ultimately, in the virtual simulation, the difference is more just kind of the camera perspective and where it sits. There's some support for like the ground interaction, particularly for the ground robots. There's some support for them moving around, but most of your data collection is going to happen when you're standing still anyway. So it mostly comes down to where the camera viewpoint is. All right.
I mean, my question or concern would be going forward, multiple agents. I mean, we've seen even in the first phase with just one robot, many of us were unable to run the simulation, in real time and had to save everything into the bag and then run off of a bag. What sort of a hardware considerations are we looking at going into phase 2?
Most likely more, but we don't have those that figured out yet. We're trying to figure out how we can do the whole ROS autonomy thing as efficiently as possible. But we're concerned about that too, of running the test bed and doing all the scoring for everything with multiples. So that's on our list to figure out how do we make that as efficient as we can. I think that's most of the questions. I'll put in a plug for the forum. Obviously, you guys have been using it. You guys have mentioned some kind of suggested improvements for next year. If you don't mind, put those in the forum. We'll take a look at them within the next probably few weeks. We're going to be meeting with DARPA and kind of prioritizing the list of changes we're going to make for phase 2. So if you have suggestions, things you'd like to see, either demands or suggestions, whichever you want to call them, put those in the forum. We'll collect all those up and put them in the list of things to do. One last thing, for me personally, moving into phase 2, I'm pretty optimistic about where we are, what we did in phase 1 and where this is going, not just from the virtual testbed standpoint, but just from the overall project and the potential contribution to the world of what this thing could do if it's successful. So for me, my word for phase 2 would be optimistic. So for each of you, what one word would you describe as your feeling going into phase 2?
A little bit of optimistic, but I try to be realistic.
Excited.
I'm going to go with prioritization, trying to figure out where are the important things to focus on, spend the time on.
Okay.
Possibility.
Online?
I would say excited. Looking forward to managing multiple robots and actually be in full control of them.
I think we are optimistic as well. We're hoping to pass through the hardware constraints and manage multiple robots with the given computational constraints. But yeah, we are definitely excited, and we're more charged up to present even better solutions.
All right. Well, thank you to the panel for participating, and thank you for the audience for paying attention, staying awake after lunch, always a bonus. Any last thoughts any of you guys want to throw in that didn't come up in the discussion questions?
The virtual testbed was super cool. You guys clearly spent a lot of time and energy, and it was just, I was not expecting a level of detail. It was just incredible.
Thank you. Appreciate that. All right. With that. Thanks, everybody.
Please enjoy a short break and return at 2 p.m. Eastern for our final panel discussion.
I think we have a lot to talk about. I have some things planned, but this is all about y'all. So definitely feel free to share whatever comes to mind as we move forward. So yeah, I guess first of all, yeah, I think if everyone can, again, just kind of introduce your name, your organization, your team name when you first speak. Would love to hear about the composition of your teams. What different expertise did you bring together? And what did you find especially helpful as you were working through this past year? Anyone want to start?
I'll start if at the end it's either me or you. So.
Yeah.
Aaron Winder. I'm from Charles River Analytics. We're out of Cambridge, Mass. We've partnered with the University of California, Irvine, and the University of Massachusetts Medical School on this. Our approach was that we thought that this competition needed a lot of flexibility in terms of how we respond to an environment. So we came with a robotic arm, and we tried to think a little bit outside the box in terms of our sensing. And we knew that a lot of teams were going to come with really strong robotics experience. We opted to, maybe think a little bit more along the lines of, how do we get sensors in the right place? How do we, get, innovative about how we measure different signals? And so that brought our team together. So University of Massachusetts Medical School is really meant to give us the guiding light of, you guys should focus on this pose or this position or this type of injury, and give us a lot of feedback about the feasibility of this in the real world. We do want to stay grounded, that competition is fun and scoring points is fun, but at the end of the day, we were really interested in making sure that this is going to be useful in the real world. So we use them to ground us a little bit. And then University of California, Irvine brought our sort of current innovative approach, which is the laser speckle, which we've spent a lot of time developing and evaluating, and we have a lot of optimism about how it's going to function. So that's sort of a brief introduction of us.
Awesome. Yeah, I'd love to come back to kind of the unique sensor packages or approaches across the teams. But in terms of the human engineering that went into team composition, how did you all approach that?
So our team is Team Chiron, and we really brought together a robotics lab, a sensors lab, and then a computational lab, right, that specializes in computations as well as AI. And then we had a nurse who was 28 years active duty, leading mass casualty incidents, and we have a partnership with the University of Pittsburgh, and they're a flight medic, so Dr. Lenny's amazing. And then we also asked Figure 8 Federal to help us with data labeling, and we did that intentionally because we know that data and how we have that data labeled so we can do segmentation models and other things is going to be really important.
Cool.
So that was our approach.
That's great. Yeah, I think another topic we can move on to is investment in data resources. I know that data collection has been a big part of this first year, especially the workshop, it seemed like, for a lot of the teams. And so I'm really curious to hear what approaches people had for just making the data they collected useful. Yeah. Looks like you have something to say right now. I can.
It's just going to make you laugh, and I promise I'll be quiet. So we actually went out to Tioga Ranch, where when they slaughter the pigs, we would actually collect the blood, right? And the old ladies out there, the older ladies out there, they gather it and they put it in Ziploc bags and they freeze it and things like that, because we wanted to know how much, since blood correlates with shock, what does a liter of blood on gravel look like? What does a liter of blood on snow look like? What does a liter of blood on grass look like? We were trying to get really creative, but it's very, very hard to tell any difference there. So I think for us, and I'd love to hear from the rest of the folks, blood was one of the absolute hardest things from a data labeling perspective and hemorrhage detection.
Yeah, wowie.
Yeah, it's a huge challenge because, I mean, as is demonstrated right next to me, red clothes exist. And trying to get something that can detect, bright red blood or, some of the more darkly colored wounds is really hard when you also have to balance it with the fact that like occasionally someone just shows up in a red cardigan and it looks like they're bleeding everywhere. So yeah, no, it's a huge data challenge there, and actually getting images of undebrided wounds is next to impossible. So that's made the wound detection in a serious way the biggest data challenge, I think, of the whole systems competition.
Was that a focus for other teams as well, the kind of wound detection side and sort
In
of
the challenge environment, they're not using real blood.
Yeah.
So you have to mitigate for the differences in the challenge environment versus the real world environment.
Yeah, I think this is a big part of, especially the virtual and systems competitions, that they are using simulation in some form or another, and so there's a little bit of a suspended disbelief required, and I think it'll be interesting to see how we can kind of make that leap into the real world.
Well, one thing I can definitely caution is we found our blood at H Mart, which was great. I mean, it's inexpensive, but man, does it smell after not very long. So. Yeah, some field tests got a little dodgy.
Oh, man. Yeah, please.
Aaron Adler from the Rapid team, primarily RTX BBN. I think that sort of touches on some of the sort of complexities of the real world too, right? It's not just like detecting the colors, it's detecting them in like outdoor environments. It might be cloudy or sunny, or it might be changing like during your run. And so calibrating things is one of the things I think we maybe realized was a challenge this year, but probably we didn't really have time to fully address it. Sort of similarly, like with the live actors, right there. And I think this was probably better in the challenge than the workshop, but like in the workshop, it was bright and sunny, and so like some people are covering their eyes up because they can't look at, like you can't ask them to look at a drone that's like, sitting right by the sun, right? And so detecting some of those things is tricky, right? Like how do you get a good view of their face, right? And I think the virtual panel talked about this a little too, right? There's lots of like pulse detection algorithms, but a lot of them are like made to work indoors against a white background in a doctor's office, and maybe they give good results, but like you're not indoors, you're not like a white background, you're like out in the field. So like, how do you account for that? How accurate are the numbers? Like those things are hard. I think that's one of the many hard things I think all the systems teams had to deal with, right? It's the triage algorithms, but then also like our team, we bit off a large bit of the things that are maybe more relevant for next year with automation, and like that's another thing. And I think one of the things that was a struggle for us because we were trying to automate things is a lot of it's about how do you get the right angles, and doing that in an automated way is even harder. So like there's a person there, how do you get a good camera angle on them to even run the algorithms you want to is challenging.
Mm-hmm. Yeah, please.
I'm Eric Eaton from the University of Pennsylvania. So we're a team that combines 3 roboticists, faculty members at the University of Pennsylvania, with 3 trauma surgeons. And so one of the things that we've been working with our team is that we have people on our team who deal with these in the trenches every day, including veterans who have been deployed for multiple tours in places like Afghanistan. And so we relied a lot on their expertise to figure out what to simulate, how to simulate it, and so forth. And I got to say, the people in our building got very used to us carrying around mannequins in various stages of bloodiness and wounds and so forth. Like some of my colleagues, we didn't go for the real stuff. We went for paint, which was a whole lot easier to deal with some liquids, because as soon as you work with liquids a few times, it makes a mess. So.
Yeah. Well, the blood that is the moulage blood, one of the things we didn't know if DARPA would do or not do is have clots, because blood will clot pretty quickly. And we wanted to make sure our models could differentiate between pooled blood, clotted blood, oozing blood, squirting blood, this different stuff. And it was almost cost prohibitive to buy the moulage blood.
Mm-hmm. Yeah. I've seen a lot of nodding. It seems like there's a lot of shared experiences. How have you all kind of learned from each other over the past week when you've been in the field, in the tent right next to each other, or how have interactions been between teams? Yeah, please.
So I'm Bethel Quick. I'm with Engineering Dynamics, a team Engineering Dynamics in Reese, and collaboration has been really great. It was a combination of, hey, we are missing an HDMI cable. Can we borrow one? How did you do on that run? What were your struggles? We do a lot of competitions, and we found that this is an incredibly it's a collaborative environment that is not found anywhere else. Mm-hmm. We're all here to find a solution together. And yeah, we're competitors, but our team, for example, we were competitors in another challenge. And as we've all talked, we've found bonds in what maybe we can do in the future, and I think that's pretty incredible.
That's great to hear. Yeah.
Nothing brings people together like shared trauma.
Oh yeah. Oh yeah, nice.
Please. We spent a lot of time talking with other teams about kind of what hardware worked well, because when you're out there purchasing different sensors or radios or something like that, oftentimes you don't know ahead of time what to get. And so having just that information about, I've tried this in the field and that works really well, it's so informative. And that even goes beyond this program, right? For general robotics experiments and so forth, just what to get, what works well, what doesn't work well, and so forth.
It was a really nice experience because we were able to collaborate and really work with other teams to see what kind of sensors we're using, because of the NDA compliance regulation, it really restricted us a lot. And being a self-funded team also put us in a place where we were really selective about what we were using, and we wanted to make sure that everything that we were procuring was actually worth every penny that we were putting in, because it took us a really long time to actually receive the products that we were ordering. And sometimes, for example, we received 2 of our sensors just last week.
Oh, wow.
And that was actually the first time we were able to test.
Oh.
But we still managed to put it there, and that was really nice. A lot of things that I was actually researching with my team prior to this competition was some of the flight controllers and other modules that are allowed to be used. And it was really nice asking other teams about their experience with it, so that next time you can actually make a better decision and order it well in advance, knowing that you'll use it. And it was really nice working with everybody, and I'm really grateful because we got a lot of help from everybody, and it was really, we had some struggles here and there since we didn't have a vehicle here. So really glad that we got some help. Thank you so much.
I would just like to recognize that this is a completely student-led team, completely student-led.
Yeah, that's really awesome. Yeah, it's lovely to see, I mean, just even, teams that combine different expertise, but also different levels of experience and kind of learning from each other is really great to see, yeah. I'm going to turn to the people who are not in the room physically, and I think switch to, thinking about surprises that came up with the specific platforms that you used. So there was a lot of variety across the teams about, UAV versus UGV, but then even within that, anything surprising that came up with your autonomous team, or your unmanned vehicles team, and how they kind of navigated the terrains on the 3 courses?
This is Derek Paley from the University of Maryland. I'm the team lead for RoboScout. And I just want to give a shout out to DTU and Coordinator Robotics. Being in the top 5 as unfunded teams is really, really impressive. I know there's undergrads on Coordinator Robotics as well, so we were really impressed by how well you guys did. Our team is a mix of students from the University of Maryland College Park, aerospace engineering students, PhD students, master's students, undergrads. We have an engineer from the Maryland Robotics Center. We have pilots and engineers from our University of Maryland UAS Research and Operations Center that bring a lot of drone expertise. And then we were really fortunate to partner with the University of Maryland School of Medicine. So one of our real key advantages is that the School of Medicine has an Air Force lab located in Baltimore, and they have the same mannequins that DARPA is using for the competitions. And so we were able to do some testing prior to Workshop 1 and again prior to Challenge 1, where we set up basically outdoor courses very similar to the ones that we experienced this week in Georgia at the Guardian Center. Just not quite as many mannequins. So we were usually working with 1 or 2 mannequins as opposed to 10 or more. So the scale of the courses at the Guardian Center were much bigger than what we have practiced on, and I think that stretched our limits, especially within 20 minutes. Course 3 with the 16 casualties really pushed us, because we do have a limit as to what assessments and entry patterns we can do from our drones. So our drones can visit all the casualties in under 10 minutes, but they can't get vital signs and they can't get certain alertness categories. So we do require our ground vehicles to visit all the casualties. And unfortunately, just for course 3 in particular, we only were able to visit 12 of the casualties out of the 16 in the time that we had. So that's definitely something that we learned from, and we're going to be migrating more capabilities to the drones for year 2, especially look at the DART team. It's just all drones, and they were really successful in terms of obviously with how they did overall. So that that's one of the lessons that we learned. I think we had, as all teams did, I think a fair amount of adversity. We had a network switch go down in the middle of a run. We had trouble with the Wi-Fi access points on course number 1. Things that didn't really happen in the workshop seemed to happen in the challenge, which I think one of the things I was really impressed with our team is the way the students and the staff handled that adversity under pressure. So I was really, really proud of them. But we obviously have a long way to go. Lots of room for improvement. So it's been really exciting to be part of this along with everybody else. Thanks.
Thanks, Derek. Yeah. Any other comments about your platform team? Your platform selection.
One of the things we did, we weren't sure what platform we would need, right? If you look at the floods right now in North Carolina, clearly your unmanned aerial vehicles are going to be the way to go, right? And even probably underwater. So out here, we used an RC car, a wheelchair, a quadruped, and a drone. And it was interesting that the RC car got stuck in the mud, and we tried to use another one to get it out. And the wheelchair one was a large base, and it was hard to navigate in certain areas. So I really have a lot of gratitude to DARPA that they gave us very different terrain to traverse, because that then allows us to really think about, from a mission perspective, the breadth probably of platforms we will need, and that will be determined by the context of the environment in which they're used. And so, as DARPA thinks about technology transfer, having that variety among our whole group will give them that wisdom, right, and ability to select.
Yeah, absolutely.
Yeah, Colin Dunlap from Patel, the drone-assisted rapid triage DART team. So for this phase, we were all aerial vehicles. We used the Skydio XD10, and we had the competition ran 3 platforms, but we have 4 available to us. So this worked really well for us this phase. I think we were able to effectively use a lot of our engineering resources because we only had this one drone platform to integrate with. It sort of standardized some of our interfaces. So we were able to refine a lot of that technology. And then as far as the actual event goes, the drones worked really well. There were some accessibility issues on some of the courses, which wasn't a factor for our drones. And then we also were very fast getting to a lot of the casualties. Course 3 was a very challenging course, but right from the start, we were able to launch 3 drones, sort of spread out over the course, and start assessing casualties. So I think that speed and accessibility were important for our approach.
Yeah, that's great. Yeah.
Go ahead.
Oh, sorry. Yeah.
So we're actually an aerial robotics team from the university, but we took this as an opportunity to transfer our existing knowledge to ground vehicles. And we decided that because we don't know about how the terrain is going to be, we're going to actually get a very rugged system. And we invested in something that was a fully customizable UGV that can be assembled within a few hours, and you can just pack it up into a suitcase and carry it, because that's how we got it here as well. So, yeah, but it was a really nice experience for us because we were transferring from a drone perspective to more of a ground vehicle perspective, just so that we could get a better view of the casualties and also actually focus on the angles from which we were viewing the casualty rather than just from the aerial perspective. And also because our UAV, we weren't able to procure all the hardware within the time, and we actually got a few things delivered to us right here. So we weren't able to test our UAV here, and so we decided not to deploy it because it wasn't tested. And it's always safer considering, there's live actors and mannequins there, so you don't want to deploy a system in a triaging situation that you've not tested your algorithms on before. So it was a really nice opportunity to learn how to transfer from an aerial to ground perspective and actually use that existing knowledge to build a platform from scratch. So,
yeah, that sounds really valuable, and I think that the portability question is very realistic, and so I think it might have been frustrating in the near term. Yeah, I think will serve you in the long term. Yeah. Did you have?
I was just going to respond to sort of both your last two questions in one experience, which is that it seemed like we were all surprised in surprising ways, and I felt like the group here we seem to be, obviously we want to compete and we want to win. I think everyone feels that sense of getting points and all of that, but it does feel like people are really trying to solve the real world problem. And then, so we're talking about what did you do with your network? What did you do with this? And it hasn't turned into this cutthroat, no, I'm not going to tell you anything because, you're going to get points and that's my loss and that type of stuff. So I feel like the collaboration here has been a nice balance of everyone wants to achieve, everyone wants to get the points, but we're willing to talk about this sensor worked out really well for us and that type of thing. And hopefully that's a solid foundation for building a new research and development area, right? Where this is going to be a community that moves forward. This launches a whole new area that's really going to be, successful, and we're motivated in the right ways towards points and winning and all that type of stuff. But at the same time, I think we are sort of invested in the long-term vision of this has got to be a thing that goes, forward from this point. It can't be the thing that dies at the end of the competition.
Absolutely, yeah. Yeah, we really want this to be the jumping off point. Yeah, certainly. Please.
My name is Amandeep from Team TTT, and I wanted to add that my focus was mostly on portability and autonomy and consisting of only aerial vehicles. But I wanted to add that I wish I had done the pivoting to UGVs as well, because the NDAA compliance, the UGV part was slightly easier to deal with from that perspective. And at least for this phase, UGVs I think would be very successful for the courses that we went to for this phase. And I'm not sure what's coming up for phase 2, but now I'm already committed to aerial vehicles, so I'm going to go for that. But UGVs, I'm going to consider it for next time.
Yeah, great.
Yeah. I Justin Peel from AirTags. I didn't introduce myself last time, but I would definitely agree. We actually went to the workshop with one aerial platform with a heavy focus on the sensing system on it, and after some analysis there, we came to the same conclusion that the way things were laid out here would be, very beneficial to also have ground vehicles. And so we actually threw together ground vehicles, basically scrapping parts around to the lab and whatever we could get on prime, and got something fielded that was awesome, except for the opposite of what the DART team found, which is integrating inhomogeneous things is really a challenge on board. So we were kind of caught up in that, but I think the real benefit to it was we were able to kind of take some of the base technology we had and push it, see where else we can apply it, how else we can apply it, and start to see like where certain aspects, like for us, the radar really provided a lot of benefit, and where, you know, we might be able to change ConOps or what can be expected of the system because of what we found.
Interesting, yeah. I think this kind of is related to the question of ground versus air vehicles, and also, you know, calling back to the, you know, the variability that real humans possess and the actors, you know, provide as you know, part of the challenge. I know a lot of teams interacted with the actors. I know that a lot of, you know, human triage algorithms involve interacting with the patient to assess their condition. How did you all think about interaction? What were some surprises there? Yeah, any?
Well, I recall sitting in one of the, you know, we built the cages because we wanted to make sure our cameras would be able to focus through the mesh, right? And that
the human shelters, excuse me. Yeah.
Sorry. The human shelters.
I think safety shelter. Let's emphasize the
safety. Okay, the safety shelters, okay. But I was sitting in one of the safety shelters and our quadruped approached. And I had never really looked at the quadruped from that position before. And I love our quadruped. I have feelings for it. And yet I was very like unnerved.
Oh yeah.
And yeah, and that was when we realized we need to, you know, the voice we use to interact should be a soothing voice. It needs to be loud enough that the person can hear it. We need to be able to hear their response, and we need to be reassuring, right? So that's when you talk about collaboration. That's when I found out my colleague here has like a real focus on that. So.
Oh, please, yeah. Nice.
So yeah, we do have a pretty big focus on the human perspective. In engineering, we often take too much and we focus on the technology, which is fantastic, but we forget who's using the technology. And we had this conversation about, because we considered it as well. I'm sitting here, I've just been through this casualty, you know, I'm traumatized whether I have a physical injury or not, and there's this drone. And some of these drones are really intimidating. And yet the same thing with the quadrupeds. And as I watched with my colleagues, I don't know how I would necessarily react. And so we did take that into consideration. And it was definitely having that perspective, I think, gave us a little bit of an edge to know that we're here to treat the people. And I think a lot of times we do forget that.
So we had some conversations with clinicians about this, because they interact with patients all the time, and the soothing is absolutely key. We also found that if you don't have any kind of voice, what happens is the robot might go up to a casualty and then just goes away, and no idea what happened at all. And so having even an announcement about what's going on from the robot's perspective, it lets the human know, like, oh, something actually happened. It didn't just look at me and ignore me, which is really important if you've just been through a trauma.
Yeah, absolutely. Oh, yeah, please. Derek, go ahead.
Yeah, just echoing what Eric said. Yeah, I think one of our biggest improvements from Workshop 1 to Challenge 1 was how we verbally interacted with the role players. And we got a lot of ideas from Workshop 1, but at that time, our spots were pretty not empathetic. Like they would say, hold still, I'm checking your vitals. And the person would be screaming, get help, and then Spot would just turn and walk away. And then a role player during Workshop 1 like yelled at Spot that if it didn't get help right away, it was gonna neuter it. And so it kind of gave us this idea of like, wait a second, you know, these role players are actually, you know, they're willing to, if you don't interact with them, they kind of just repeat their script. But if you do interact with them, then you know, that's a good source of information. And so we actually developed a large language model that we run on the edge, and we engineered a prompt that, you know, basically establish that, you are a robotic medic in a mass casualty incident, and you need to interact with an injured person and assess these things. And over time, we kind of tweaked it. We had to say, be concise. We have to say, be empathetic. And that was really exciting for us because it felt realistic. Of course, when we got to course 2 and there were no humans and we're just, asking mannequins if they have a leg injury, that didn't feel very useful. But it always kind of surprised us a little bit how effective it was, especially when we had real humans, talking back.
Yeah, I'm curious about other kind of algorithmic approaches. Yeah, whether large language models or, we're asking you to do a lot of different things at the same time.
We did the same thing with Whisper AI, so we did something similar there. And then the other thing we did is, instead of just multimodal sensing, we did joint inferencing using Bayesian models. And that helped us with confidence intervals and understanding the probability that we might have missed something and accounting for it.
I think, just to build off of that, I think what you just said is really key. Like, this idea of having the integrated sensing and inference process is so important for triage. Looking at the sensors individually are informative, sure, but it's really what happens if, like, for example, if a gunshot wounds across the chest and such, you might just have a little bit of blood, which under the current rules would be not severe hemorrhage, but there's going to be severe hemorrhage because their area around their heart was just shot, for example. So taking and only integrating these aspects together, the visual, the sound, the other, you mentioned radar and such, all these sensors together really is what gives us a complete picture about what's going on with that individual patient.
Geez. So just to build up on that, I was just mentioning that in the virtual panel as well, that the approach for next year, one of the things I wanted to see that if I can change is, instead of having segregated models doing their individual prediction jobs, having a more holistic approach where the model inferencing is dependent on each other and builds up as a complete answer from the system perspective.
Did anyone use sensor feeds, like perform inference across platforms? Yeah, okay, yeah. Any surprises there? Anything you learned this week? How the different platforms work together?
We burned our board out on our UAV hours before the first run, so then we ended up having to hardwire connect with the radio. So we didn't get to really test it the way we want to, but we did integrate across that and tech. So we're really thinking about not just what is it that we may be learning, the probability of an injury pattern, how do we then integrate that into a broader mesh that can then be communicated to DoD, national, state, or county responders.
Yeah, so it sounds like you're really thinking about like the medic using the system, not just the casualty on the field.
Exactly.
Yeah.
No, go ahead.
Sorry.
Go ahead.
We also have a TAC integration for the same reason, and especially the geolocation services that it provides. We saw could be really useful for, once medics have this information, how exactly do they come up with an approach plan to get to the people who need the most severe help?
Exactly.
Let me go with you next, then we'll get
Yeah, so I'm pretty much going to echo what my colleagues said, and we kept in mind throughout this entire process that we aren't replacing the human element. We are an attribute for them to utilize, right? Yeah. And so we just wanted to make sure that the first responders, the military, whoever is utilizing this program, the system, is going to get the information accurately, efficiently, and quickly. So that they can act, and we find that it's really important to keep our first responders safe, and it's not just about life saving; it's about life preservation as well. So keeping in mind of that human element.
Great, yeah, and thank you, Derek, for raising your hand, Daniel. Yeah, I think because I'm facing the people in the room, if you can raise your hand, that's great. Go ahead, Derek.
Daniel, did you want to jump in?
Go for it.
Okay. Yeah, so, here I am thinking, our inference engine is kind of our secret sauce, but I guess a lot of folks are doing that. I just want to echo what people are saying about, integrating and accumulating evidence over time across sensor platforms, across sensor modalities. So our inference engine is on our base station, and it does assimilate information, observations from our UAVs and our UGVs. And, one of the things that I was going to suggest actually going forward is, it would be interesting in the reports that we submit to DARPA if we were to be also able to submit a confidence, because that's one of the byproducts of our inference engine is we do have a confidence level associated with our assessments. And to me, that is useful information for a medic, because otherwise they might mistakenly put too much emphasis on the robotic triage. But if the robot says, the heart rate is, 65 beats per minute, but I have very little confidence in that, that's different than saying I have high confidence. And so we were actually thinking about overloading there's a system string that is permissible in the casualty report. We were thinking about maybe overloading that with a little bit more information, since it's just a character array. But it may be something for DARPA to consider is, and I don't know how it would factor into scoring per se, but it does seem like a useful output if folks are using inference.
Yeah, we definitely hear that suggestion. We had a similar theme in the data competition panel as well. Yeah, go ahead.
So I want to add one other thing that we've already started working on. So like other teams, we certainly have a TAC interface that we've been developing. One thing we've been adding is the ability to describe the location and clothing of what the person's wearing. So trauma surgeons say this is a really important thing in many cases, especially for someone moving around. GPS coordinates are great, but that may not be enough.
Mm-hmm. Especially if they're moving.
Especially if they're moving.
Yeah, absolutely. Did you have something?
Yeah, I was going to add to that I was thinking if there would be a comment section or something which does not fall into the categories of the report, and where we can add information like that. At location this person wearing this has, and one of the things I was thinking about when I was developing the model was, what if a person was an amputee already, but they're not amputated at the scene? So should I add a comment or something? But since then I've been thinking if there was a comment field or something to add extra information to the report.
Yeah, no, these are great suggestions. Daniel, I want to go back to you in case you had something to add.
Nothing at the moment.
Okay. Can you introduce yourself, I think, since I haven't gotten to you yet?
My name is Daniel Peets, and I'm part of the team Coordinated Robotics. I am one of 3 undergrads out here on the trip to Georgia, and working with Kevin Knadler and Jason Isaacs. So it's been a great experience so far.
Nice. Yeah, thanks for joining us. So I wanted to, we talked a lot about the human actors. I think we brought up some of the differences with mannequins. In what ways are you kind of, we can definitely tell the difference between mannequins and humans. In what ways are you kind of, incorporating that into your solutions for the purposes of the challenge? Or are you, intentionally ignoring that just with the kind of bigger picture in mind? Yeah.
So we found that the availability of data is difficult. I think this was talked about before. And we went on a big hunt for realistic data sets. And I, unfortunately, since I came through the biological sciences, I was the person who had to go through the medical triage databases and look at pictures and all that type of stuff to compile our database. But I think what we realized is that for a lot of our computer vision, there is an analogy between what the human eye and brain can do by recognizing that, okay, this is not an individual, but this is injured in this way. And so we leaned into synthetically generated data sets and the mannequins, quite a bit to sort of augment our data set. We always wanted to do the final testing and the final validation of our inference on humans, under simulation. But at the same time, I think we tried to draw upon as many different sources, regardless of their realism, because there are sort of the common attributes that the human brain can recognize immediately if you're watching a movie or you're seeing a video game depiction of violence, or what have you. There's going to be common features that we wanted our computer vision to be able to pick up on. And once we fed in a data set that was many thousands of examples long, we actually found that it did a fairly good job of picking out some of the features that you would sort of try to describe. An amputation is a severance between the limb. There is probably gore, or there is that type of stuff. That stuff sort of popped out in a way that was sort of gratifying without having to rely on the exact replication of the scenario. We sort of have to provide an overall description in the examples that we use.
Yeah, that's great. Yeah, I think the idea of collecting real data for this sort of application is going to be challenging no matter what. So yeah.
One of the things that our amazing students really found was in the heart rate algorithms that we were building, that skin color made a huge difference. And so that's something we're really trying to pay attention to, and really trying to make sure that as we build data libraries, we're taking into consideration all different skin colors, right? The mannequins are all Caucasian.
Mm-hmm. Yeah.
And I don't even know if they make them in different skin colors, but I guess that's something to consider in the future. And related to that, I know there are some data libraries out there, but they're very limited. And the one thing I would hope to see come out of this DARPA challenge, given all three, components of it, not three phases, but the three components, right? The synthetic, the data, and this, is truly accessible data libraries that are representative of the population and are accessible to other countries that are affected by climate impact, and need to have the capability to have disposable, autonomous triage capabilities that can recognize their population regardless of their ethnicity or race or whatever.
Yeah, absolutely. Yeah, and I will say just that is definitely important from DARPA's perspective. And I think it's great you're bringing up some of the points that you saw in the field today. On the analysis side, we're looking into that. And so I think it's definitely an important thing to keep in mind, and we're keeping tabs on, on the results. So thank you for bringing that up. Yeah.
I was just going to echo what you're saying. That was a big thing for our team as well, is we do not want to be putting a lot of stock into a system that has any sort of inherent bias. And so, although this is maybe part of our team's approach that is a secret sauce, we specifically focused on the laser speckle for that reason. Laser speckle is a lot less susceptible to the absorption of melanin in the skin and that type of stuff. We also did when we measure, and so yeah, I'm going to overshare a little bit because I think this is really important that this be addressed. But when you point the laser speckle at the chest, you actually get a ballistocardiogram, which is going to be not distinguishing the the color of the skin. And then I'm also really interested in this radar measurement as well. Do you get sort of a so there are these additional modalities beyond the RPPG that everyone has focused on that I think are really going to mitigate the danger that we're favoring one demographic over the others in terms of how we can triage them. So we as a team are very happy to help anyone who wants to implement that type of stuff in the spirit of collaboration over competition and that type of stuff. We'd be happy to happy to help you out with that.
That's the collaboration that this whole group is talking about. Mm-hmm.
Yeah. And I'd like to add that we've actually done some pretty extensive studies on PPG and skin color. And a lot of the times, because the physics of the PPG signal itself is a little misunderstood, it's not the same physics as a fingertip pulse oximeter, you do actually see a pretty good range across of signal quality across skin tone. And for the most part, in our experience, darker skin's harder when there's less ambient light, and lighter skin's harder when there's way more ambient light. I know myself, I've saturated a sensor or two, but that kills the signal. So it's a very important thing to think about, and it's something we've spent a good amount of time trying to study just from the visual side, because The failure points we saw were, once again, a lack of data, where most data tends to, have skin tones that are in a certain spectra one way or another, and if you can't recognize that it's exposed skin, you're not gonna get the signal that's inherent in it.
Yeah, can I make one more point? Sorry. This may be something that DARPA can do to help us out, and sorry, Derek, I realized your hand was raised, but we actually looked for data sets, and there's end user agreements in place for a lot of these. And I wonder if there's a way that DARPA could sort of bypass some of the restrictions on how the data are used, because we always came up against the idea of we're a commercial for-profit company, so they think that we're going to use this for commercial benefit. And there actually are a lot of data sets that are looking at the different skin tones and how can we use RPPG more effectively and all of that. But we always ran up against this wall of the data are out there, but when we try to fill out the end user agreement, we were always sort of stymied. So if there is a way that we could potentially use the machinery of DARPA to get that data available to us, I think that would be really helpful.
Yeah, I think definitely, shoot an email over, and I think they can definitely look into it.
The other thing that might be worthwhile is, I don't know how other teams would think of this, but we'd probably be willing to share a lot of our RGB data, especially, and probably radar data too, just because, in competition, we're trying to make ourselves better, but in collaboration, we're trying to actually get this done and field a system which does what we hope it to do. So if there could be some shared repository, it might be something like we could, participate in.
That's a really cool idea. Yeah, you want everyone to bring their A game, right? So that's Derek, go ahead.
Yeah, I just want to speak to this point about having these annotated data sets. That turned out to be a pretty big effort for us, and initially we had not had prior experience, at least the majority of the team, with human subject research, and so that was a little bit of a barrier to entry for us. And we've kind of overcome that. So we've been exempted from IRB from our university, provided that we de-identify the individuals, using a mask or something like that. And so a big part of our effort has been training image classifiers by building these annotated data sets. We have a lot more ground level views of casualties than we do aerial views. So that's one of our ongoing challenges, to continue to bolster our training data sets. But just in terms of making them publicly available, I think that this is an opportunity for using mannequins and synthetic data, which then won't have the restrictions that the human subject data has. And so that could be a way going forward that we make publicly available annotated data sets that would help the community.
Yeah, absolutely. I think that's a great legacy, all of the data collected and the collaboration and sharing of those resources. Yeah. I was going to switch gears, but people are pretty excited we can stay on this one. Okay. So I was curious, it's been an exciting week. And I've been in the room, staring at y'all's screens and pointing cameras and stuff. But, I was curious what the feel was like in the tent during your runs, how your team communicated during the run, if there were any surprises about the kind of team environment, and what you changed from run to run, perhaps.
Stressful.
Yeah. Okay. Yeah.
So I think it was a really nice challenge for us because it was such a huge scale. We never imagined a competition of such a scale, and just having a scenario that was replicated so well, especially the plane crash scenario, I think it was so realistic. And while we were traversing through the course, we had this team structure, and we'd given each other responsibilities, and we learned how to really work together as a team and communicate with each other and change strategies right on spot. Mm-hmm. So we didn't initially plan on using 2 rovers, but we switched, and we actually decided to send in one just to explore and figure out where to send the other 2 systems, and to see how fast we could get it there and where to position it so that we could get a good view of the casualties. So it was really nice just to go there and work together as a team, and we learned each other's strengths and weaknesses so well that we learned how to set up at the base station really fast, and it was just really surprising to see how you come together and solve a problem like this of this scale in real time, and you actually learn so much operationally as well, especially like when it comes to making decisions about the different platforms that you're using, deciding what to use and what not to use right on spot. So yeah, that was a really nice experience.
Great.
We were kind of like the Tower of Babel when we started, where you had team members that knew ROS 2, you had team members that knew Python, bridging that, right, so that you could move things from your ROS 2 nodes over into your Orin and process them and get them out. It was very interesting, and since we're mostly a team of students, they were all focused on their research interests. And so we had a lot of silos initially as they were solving for their algorithms. And then at the workshop, they really saw that there is no I in team, and that it's got to go horizontal as well as vertical. And I saw them learn to respect the strengths that each individual brings to the table. And frankly, they're the future, right? And so this was very exciting to see.
Yeah, it sounds like a great learning experience.
Yeah.
Yeah.
So from the University of Pennsylvania, we're a team of, in addition to the faculty, we have a set of doctoral students, master's students, and undergraduates who have worked on this project. And we're here with a set of, I think we had 3 PhD students and 3 master's students who came with us to the competition. And it was kind of amazing to see the master's students get experience with things that they would never have experienced before in the classroom setting, including setting up a real military-grade radio system, for example, and even everything from making sure batteries are charged correctly, which is super critical for a robotics project. And so all these kind of like just the skills that you could, it's lovely to see the PhD students pass these on to like kind of the next generations.
Mm-hmm.
Yeah. And this is full end-to-end system development,
yeah.
Right? Mm-hmm. From your data collection, your data cleaning, your data processing, to your output. So to be able to participate in something like this and actually see it through, right? Most adults in industry don't get that opportunity.
Yeah, you get in your own field and you stay there.
Yeah, so this helps, I think, people also appreciate what does it take to move from bench to application.
Just a quick anecdote. So we actually had 2 failures to launch due to network problems, which was really stressful. Our main network guy, unfortunately, had a personal conflict come up, and he couldn't participate in the first session. So
you have somebody to blame, so that's good.
Well, we brought in Nick Bender, one of our engineers, who's an extremely smart person, but he was shouldering a lot of responsibility. Not only getting the robot working, all of a sudden he was on network duty as well. So we had our first failure to launch, and he was distraught. And then we went out with we brought our own Wi-Fi, and suddenly we had an unknown environment where we were channel hopping, we were rate hopping, we were doing all sorts of stuff that was just making our robot not function. We barely got off the line. He was very excited about that. But one of the things I think we realized as a team just was a learning experience for us was we sort of found that it didn't do any good to get after him, that we just sort of like kept encouraging him. And he pulled a rabbit out of his hat on the 3rd run, just a Hail Mary, like college football style, that got our robot running and got us some points and all that type of stuff. And I think that was one of the things that we learned about this high pressure environment is when you have a team, you sort of have to keep believing him, you have to keep like encouraging him. And that was one of the dynamics I think came out of this is you have to, don't get all stressed out, don't get all up on someone's, business if they're, failing or whatever. As long as you keep encouraging them, they can do something at the end. So I think that was the biggest takeaway we had was just, lean on your team members even when things are going well, and a lot of times they'll come through for you.
Yeah, it sounds like a really positive result, if not what you intended, yeah.
So we had a similar experience, and being that the only time we had previously interacted was as competitors, I think our shortcoming was also our advantage. We ended up working really well together because of that. We're continuing to encourage each other, like, okay, fine, we've got another run. Okay, fine, we've got another run. Okay, we'll get it next time. And having that inner team, like, bolstering each other, I think, because we are small, and Amandi can probably attest to that, that we felt some level of intimidation with these 10-person teams. We're like, oh my gosh, what are we gonna do? That we were able to come together and work together, and with the support of our colleagues too, which was really incredible.
Yeah, that's great, yeah. Yeah, Derek, go ahead. Thank you.
Mm-hmm. Yeah, I just wanted to say that, we definitely, I was really impressed with our team, their willingness to overcome adversity. We had, one late night coding session where we were hand flying the drone around the lobby of our hotel. That was
Yep.
memorable.
Yep.
The students seemed to take that in stride. It was way past my bedtime, so I was getting a little stressed, but yeah, that was pretty pivotal for us going from our first run to our second run to get some things tidied up. But during that process, while we were sort of thinking about things at a high level, we calculated that if you just guessed randomly, you could actually do pretty well on the casualty report. We calculated that the expected value of random guessing without golden window points was almost 3 points per casualty, and if you added golden window, it could be almost 4 points per casualty. So we were very happy that we were 0.3 of a point above random guessing on our first run. That was a relief to us. But I think one of the things about the points, as we look at them, is that I think it's really critical that the overall intent of the program be reflected in those points, because otherwise there can be a little bit of a gap between, developing robotic triage for the real world and then developing robotic triage to win a competition. And so I think DARPA's done a really good job of that so far. But since we only have 2 minutes left, I was hoping I could ask a question of DARPA about, what's in store for phase 2. I think the phase 2 qualification window might already be open. I know it's due in about 5-6 weeks, something like that. So, we're all kind of basking in the challenge 1 glow right now, but on Monday we're going to be thinking about phase 2. And I was wondering if there's anything that you could reveal about what we should expect.
Well, I think that is a great question, and I know that JP is coming up in a few minutes to maybe provide some insight to next year. So maybe hold tight for a few minutes. And I know we're kind of coming up on time, but I did want to hear from some of the teams that we haven't heard in a few minutes. What's your next step when you get home?
Well, speaking on behalf of DART, next phase we are planning on bringing in a UGV. We recognize that there may be some casualty scenarios where a full UAV solution might not be able to get to certain casualties. So that's something we're really excited about next phase. We're going to continue to improve algorithms. So we at Patel have an IRB approved human subjects research study. So we collect a lot of our own data that we use to continually improve our algorithms. And we have some sensor changes, some sensor upgrades coming in future phases that we're excited about as well.
Nice.
We have a lot planned for phase 2.
Cool. Actually, I really like this question, so I'm going to use a little extra time. So maybe if we can just go down the line. I'd love to hear what.
So we're actually thinking of definitely using the UAV this time, just to work more efficiently, I think, and get the aerial perspective as well, because that might just optimize the whole triaging a lot more, make it a lot more faster, and also working with more data set, because we had very limited data set, and it was mostly the DARPA provided data set that we were using, and we weren't really able to test in real life because you can't ask people to just come and, though sometimes we would paint our hands and stuff and try to get our cameras to detect that. But we're really excited about getting some better hardware as well, because a lot of difficulties that we faced were because of the hardware that we were using. So better resolution cameras and just more efficient and less sensitive sensors, I think, that can adapt easily and that we can actually use to get better data.
Yeah,
so
cool.
Really looking forward to that, and also introducing more autonomy to our systems than we did this time, because mostly this time was manually operated.
Yeah, great,
yeah.
Great, yeah.
Yeah, so, I mean, taking that, we were all manually operated this time, so autonomy is going to be a big step next time, but I think it also gives us a lot of opportunity for feedback between, the measurement algorithms we have, which, I mean, From our perspective, our score was disappointing, but our algorithms actually performed really well. And so we're going to build off that and start to look at, how we can integrate those solid measurements into an autonomous system and interacting between the various different platforms to really get, a quick and thorough picture of something, like one of these fields, which I'm sure pretty much guarantees we're not going to have anything that looks like one of these next time.
Yep.
Thanks. We're going to have a hard focus on upgrading our sensor package, definitely. We're going to have an exponential, probably to a power of 10, increase in processing speeds. Autonomy is another one, integration. We've got our work cut out for us, but we're really excited of the possibilities.
I think our big focus will be on the symbiotic relationship between mapping and planning and the joint inferencing output so that we can, as we get faster, understand how to remap and plan after the first initial triage so that you can have triage over time. And then how do we express that on TAC so that they can start to see compensation and decompensation.
Cool. So we have a large autonomy stack that we've developed over the years. It's multi-agent by default, able to handle denied communications, distributed sensing and so forth, and synchronization across the different robots in terms of sensor fusion. We didn't deploy any of that at all in Challenge 1. So we're really looking forward now to taking kind of the machine learning algorithms that we did develop and link them into the autonomy stack, both for active sensing and just to create the entire picture of what the system can and should do.
Yeah, great.
I think we're looking forward to new sensors, but also trying to shift some of the processing on board where we have access to more of the data. So like right now we've got super high resolution video, but our downlink is pretty thin. So you can't take advantage of the fact that we have these high resolution images. So the hope is we can do some of the processing on board to try to extract the key information and transmit that back rather than trying to transmit a video stream or high-res images.
Yeah.
For me, it's mostly planning for time and budget management so that towards the end, I'm more prepared for all the aspects of it and potentially expanding the fleet, maybe adding a UGV to the mix as well.
So we came with one Husky, and anyone who knows the joke, Chad, the network technician, named it Brad. And Chad is in the back of our car for parts. So we're going to bring Chad to life. So we'll have two Huskies that are going to be traveling around. We're going to add a UAV, and then we're also going to expand our sensor suite.
Gotcha. All right, and then last but not least, those online. Daniel, what's next?
Yeah. So for our team, this competition, we chose to bring 5 ground drones, and that worked pretty well. But moving forward, I think it could be good to add a UAV to our fleet to help either maybe scout things out or just get to places that might be more difficult for our ground drone.
And Derek?
Yeah, I think one of the things, in addition, I mean, we're kind of in the same boat as everybody with the new sensors, new algorithms, new hardware, new this, new that. But I think one thing I haven't heard is this, is how to sort of manage, personnel, team personnel over time. We have some of our students are graduating, some of our students are going on to PhD programs elsewhere. And so that's always an interesting challenge in an academic environment because you have to maintain institutional wisdom as your workforce kind of comes and goes. And so that's going to be interesting how we manage that over time. And I'll let you know, I guess, by the end of this month, how much funding we'll have that will factor in, of course, to our personnel decisions as well.
Great. All right. Well, thank you, everyone, for participating this week and in this panel. Really great discussion.
Thank you so much.
Thank you.
Thank you.
Please welcome back to the stage DARPA Triage Challenge Program Manager, JP Cretton.
Well, I want to thank the participants in all three of the panels today. First, for just being willing to be in the panel and share. This is a competition, so it'd be totally understandable if you were not willing to share your insights publicly, but you were willing to share. And I think that speaks to the sense of community that we all want to develop here. And I think that really came through in the panels. You know, ultimately, this is about improving medical care, and we're going to learn faster together. So thank you for bringing that spirit, even in the context of a competition. Your comments were extremely valuable. So we're all taking notes like crazy, and we're going to bring that back as we're finalizing the plans for next year. I also want to thank our fantastic moderators, Ben and Wes. Let's please give them a hand for leading great panels. All right, so we'll close by looking ahead to year 2. It's going to be harder. It's going to be more realistic. It's going to be more interesting. We'll start with the data competition. So we're going to have more data. Our partners at University of Maryland Shock Trauma and University of Pittsburgh had provided retrospective data that they already had to get us started this first year. They are collecting data prospectively, and we're going to periodically bring that over into the data competition. They're going to continue to collect data and provide access to that for the rest of the DARPA Triage Challenge. But they're also introducing new types of data, new sensor modalities. So in year 2, you're going to get access to pre-hospital ventilator data. So this is from the medevac helicopter. Another unique contribution of this data set. I don't know that that's accessible anywhere else. We'll also have pupillometry data from the trauma bay. And we want to see how those new modalities affect your ability to predict life-saving interventions. And we'll have additional modalities beyond those in phase 3. As you have experience, and as we talked about in the data panel, the data already is noisy and has some dropouts. And this is really a core part of the DARPA Triage Challenge, that we want to see how your approaches work with real-world data as it comes off the sensors in real time. So this year, we may degrade it further to simulate an even more challenging environment like a combat setting. And then for the systems competition, and this may apply to virtual as well, we have a lot in store for you. All of this is on the table. Degraded sensing, so smoke, darkness, obscuring obstacles. Casualties will not all be exposed as they are now. They might be partially buried, partially occluded. Dynamic obstacles, we plan to have people walking around on the course, and so casualties who are injured but well enough to walk around, and that introduces some significant challenges. Dynamic casualties. So, you know, we had this golden window in the competition last week to really incentivize you to try to get at those most critical injuries fast, and we still want to incentivize that. But that golden window is fixed for the run, for the course, and it'd be a lot more realistic if it was specific to the casualty. So the golden window should depend on the casualty's injuries. So that's something we're excited to introduce as well. Terrain obstacles, you may see additional challenges there, although that's not really what the DARPA Triage Challenge is most focused on. And so it's not our intent for that to be the differentiating factor. So I'll leave you with one last teaser. It's possible that one of the systems competition courses could look something like that. So year 2 starts now. So please visit our website. Hope you're working on your qualifications. For systems and data competition, you've got till the middle of November. Virtual competition, that's going to be open for a lot longer. But make sure you know those requirements and those timelines, and we hope to see you all back next year. Thank you.
This concludes the DARPA Triage Challenge Event 1 Award Ceremony and Seminar. Thank you for joining us, and we hope to see you at the next event.